Okay, my name's Greg Mckaskle, and I introduced myself to a great degree yesterday, but just a brief one. I work for National Instruments. I'm on the Control Systems team. Alan asked if he could borrow a RoboRio, and they're in scarce supply right now because we're starting the beta. So I said, how about I come down and I'll bring mine. So,
even better.
So for those of you who didn't see it yesterday, I do have the beta stuff and the alpha stuff and all that. I can pass it around. And what I thought I would do is sort of focus on the initial stuff. So if you're a rookie or you haven't been involved in programming before, show you where some of the resources will appear for the 2015 kit. If you've done this before, you may know this is here. Turns out a lot of people don't know. They just wing it, and they know what they know, but they don't know where to go get the stuff they don't know. So I thought I'd start there. So this is the first website about FRC. I assume you've all been there. And the FRC website is confusing. I'll admit that. It does have some good stuff on it. It's just hard to find it. So I thought I would start by showing you a couple of useful places.
I'm told they're reworking it.
Yeah, they're always reworking it. Yeah, exactly. So this is the FRC page, and the resources link contains, I don't know if I can stay on it on this little screen, contains some useful materials. So every one of these links is good. Kit of Parts actually has a lot of information. It's a good launching point for the things that come in the bins, as well as the things that other sponsors provide, even software pieces and stuff like that. So it's a weird name, Kit of Parts. It's very internalized, but all of these links are good. So as an example of where I was talking about the control system yesterday, there's some really good tutorials on here that will help to introduce the pieces. Getting started with the whatever year FRC robot control system. And you go through here. This will eventually bring you to another good website, which you might want to know about, which is called the Screen Steps Live website. Or this is actually posted on WPI Live. Screen Steps Live is this sort of wiki-like documentation tool that WPI uses and first has adopted, and we use it a little bit. And basically it makes it very easy to just throw content on a website, so pictures and text. And so you go through, and here's various tutorials they have. Here's their vision white paper. It talks about what they're going to have on the field and the math behind the optic issues and the math and stuff like that for whatever vision they're doing. I'll go with this one, for example, though. Pick hardware, software, whatever you want to do. And it eventually gets down into, here's your batteries, here's a little blurb about it, here's your circuit breaker, here's your PD, here's your breakers. And for you to read through this, for you to have students read through this to verify that you know what is required or know what's provided is really, really good stuff. So they do have good materials on the website, and if you're not on a projector, it's even better. Poke around on there, specifically under that resources tab. And you might find that just going to the WPI Live, Screen Steps Live, is good enough. You will find most of the stuff there. That's probably the most useful subset. There is stuff on there per language. If I go back a couple of links, let's see. There's getting started tutorials for LabVIEW, C++, and Java. For slightly more abstract, WPI Live programming tools, command-based programming, debugging, smart dashboard, net console, lots of stuff that's software specific. This is the kit of parts tends to be a little more hardware specific, data sheets and stuff. This is a little more software specific. Okay. So
like getting started with Java, does that give you indications of what environment you should use and how to program it?
It starts with installation.
Okay.
And it goes to various configurations you'll need to do. There are a couple of choices for Java tools. You can use the Eclipse or the NetBeans, and tells you how to do configuration. Okay. If you do the installation, you don't have to do that much configuration. Tells you how to make your basic first program, how to run it, debug it, and so on.
So we've got 3 different pre-rookie teams here, and I know that first provides a key for the pre-rookies. Is there a good way to get a key to I don't know, using LabVIEW or whatever, right, and installing that? And is probably the best thing to do just find another team and get one of their keys, or an activation key
I think that is a great way of doing it. Because not only do you get the tools, but you get the knowledge that another team has, the input, the training materials, that sort of stuff. So I would, definitely recommend visiting another team and letting them help you out. If you have access to the 2014 stuff, what you'll find is that most of this is going to be true for 2015 as well. It's more an add than a redo, right? The software is different, but it's overlaps by like 95%. So I talked a little bit about the differences in the hardware yesterday. I will eventually get to talking a little bit more about the software differences, but let me show you a third website, which is...
So Greg,
yes.
from what you said yesterday, basically the software that you already have should be working on 2015.
Yes,
The backward
yes,
compatible.
the subset that's common will work.
But they probably have
And
more.
there's new stuff.
Yeah, new stuff.
Yeah, the new stuff is more what I'll talk about in a minute, and some changes, but mostly new stuff. So National Instruments also has our own /FRC website, which, here we go. So if you go to ni.com/FRC, ni.com is the National Instruments website. I know this doesn't say the simple one, it turns into that on the server, but ni.com/FRC will give you a lot of information, tutorials, tools, white papers, all sorts of things that you might find useful if you're using LiveView, or if you want to look at the vision stuff, or if you want to use something that you don't find on WPI Live. So basically, we have engineers who donate time to FIRST, either locally or with FIRST specific, and they do training. And a lot of times they will put up articles on here as well. So you might find them on WPI Live. That's where Brad, students would just put stuff up. FIRST may have their engineers put stuff up there. So these 3 sites will cover it pretty well. And you'll find different things on the 3 sites. So, yes?
Also, the forums on the NI FRC website are pretty good. It seems like some of those guys troll that website.
Yeah, so there's the FTC forums, there's, let's see, where did they put the forums now?
Yeah.
Here we go, right here, at the top.
So you can ask questions.
Yeah. And in terms of what you will find there, I downloaded the FTC. I'm not going to go through this unless you guys make me. But, this is the kind of... Okay. This is the kind of stuff that will be up there. This is a step-by-step, how to use LiveView. So it goes through 4 different tutorials. They take about 30 minutes each. And, this is pretty... step-by-step things. How to install the software, exactly what you're going to see, exactly what to enter. You may not need to do this. If you don't do this, you may also stumble, because there's often little things like, oh, that's not the right serial number, or you skipped a step and start over. So, but you'll find all of the tools, the WPI Live stuff, the FIRST stuff, and the NI stuff. Somewhere on it, there's usually step-by-step. If you want to go at this pace, they'll lead you through. Some of your students may not respond well to that, or your mentors, so they can jump in and do whatever they want, but if they fail, remind them that there's a manual.
For C++, I've always found that I print all the documentation, because there's usually something last minute that is not part of the official FIRST documentation, but is in the package. And when I print that out and follow the directions very carefully, it always works. And those on the team who did not do it, it never works.
Okay, so now, give me a second, because this is what happens when you have virtual machines. And in fact, I may come back to this. Because I need to change the resolution on my PC, and I have to be able to get to something to let me change the resolution. So, but then I'll show you more stuff. So, any questions on training materials or specific things about the 3 development environments or languages?
And the new stuff's like out there someplace or not?
The new stuff really isn't. This is one of those conversations. So FIRST likes the concept of the kit parts. People keep telling you what's going to be in it, but they don't really know. I don't really know, right?
You
They may not let you
make very good guesses.
They may not let you use wheels this year. You don't know,
Yeah,
right?
okay.
They
More
would
than
see
likely,
pitchforks.
you know,
Uh,
this is all educated guesses.
Okay.
But they do like to have some surprises in there. Oh, it's a new kind of sensor. There's a new kind of widget or doodad or something else in the kit, or the belts. You know, we're gonna try to encourage teams playing with belts instead of chains.
They announced that, though.
Yeah, they did. And this was in the past. It was an absolute mystery, you know. And it's progressed to where it's like, yeah, you don't even get everything every year. You're supposed to reuse things, so you know that those are there, and you more or less know what's going to be in the kit. There are some surprises. So anyway, the software is in this funny middle ground of where, like, is it supposed to be a surprise or not? We don't want to write new software every year and change languages and just mess with people. So for the most part, we want to keep it the same. Teams want us to keep it the same, so we do. But the newer versions aren't made available until the game is announced. Part of the reason is there are usually examples and things like that in the code that help you with the game, right? Or help you with the sensors or help you measure something. So if you get that too far in advance, then you start to figure out what the game is.
I gotcha.
So this is a transition year, and I think what's going to happen is that they are going to make some of the hardware and some of the software available a little in advance, but they don't want it to turn into, you know, you've already got the stuff. Okay. So I don't exactly know.
Flying water game.
It could be the flying water game year, the subterranean water game, whatever.
Is this a good time for the rookie teams and young teams to figure out or to talk about the different advantages of going from one language to the next? If you're a rookie team, you should just start with LabVIEW or Java or C. We struggled with that our rookie year, and it's been a point of debate every year since then.
In a really quick summation of the way we do it is whatever resources you have is the way you go. So if you have a bunch of people from NI mentoring your team and you have anybody who's a LabVIEW expert, LabVIEW is a great option. If you have a bunch of kids who are all AP computer science kids and all know Java really well and won't have to learn syntax, the Java system works very well. If you have a bunch of C++ programmers, C++ works pretty well. Like there's all teams who compete very well. All of the programming language of C and Einstein, so you can win with whatever it is. It's just a matter of what resources you have, what your teams want to do, that kind of thing.
And typically the advice I give to teams that don't have any programming experience is LabVIEW, just because LabVIEw is used by a lot of teams, and so I feel like it's cheaped out by, you get a lot of quick answers.
Yes and no. If I go to a regional and I ask for, if I'm trying to find a LabVIEW expert, it's pretty tricky if NI people aren't there. Like, off the top of my head, teams in locally in Houston at least, there's
Like
there's like
We
no.
would go to regionals, and Aaron, when he was
Yeah.
on our team, we called him Superman, because he would help 10, 11, 12 teams with language.
Yeah, like I'll have to do LabVIEW help every once in a while, and that is not a good idea. Like I've programmed, one real competition robot in LabVIEW, and that's about it. I know it a little bit enough to help teams, but it's hard to find people sometimes. But if you give me, we do our robot in Java, and I'm the code reviewer, so I can fully do somebody's robot in 20 minutes or so in Java, but just not as fast.
Yeah, I found that whenever I go to rookie teams and talk to them, they don't have any programmers. I usually show them LabVIEW because I can show them how to add a motor and a button in like 5 minutes, and I can like their help. I can call in for help.
It's
Get help
yeah,
and their examples.
depending on who's helping you and things, like if you're a rookie team and you want my help, I would much prefer you're running Java because I can help you over the phone and tell you blind what things are most of the time. If it's LabVIEW, I'm learning too. Like I'm researching and doing the help and everything else.
Our way of thinking in 2009 when we were rookie year that we had 0 students with software experience of any sort. And so we kind of made the choice that starting from ground zero, LabVIEW was probably easiest to pick up and get doing something quickly. That was my assumption. I don't know if that's true, but that was my assumption, and we kind of gone with it.
I think most of the high school now have like introduction to computer science, and they start using the Java.
Right.
Yeah.
And that's why that's why we teach all of our every sophomore at Straight takes AP Comp Sci. So we have every boy who's been over a sophomore has Java experience on my team. So
See, a lot of schools don't really have good programming classes.
All right, so my turn. You've heard though that there are strong opinions, and basically all 3 tools are very capable, right? In fact, the split now is, we measure this stuff. The split is now, there are more LabVIEW teams than other teams, but it is evening out, with LabVIEW and Java being somewhat close to each other. and C++ teams down, there aren't as many. That may actually change with Linux because they're now a protected process. So the goal was to have 3 languages that people would be exposed to. Actually, originally the goal was to have 2 languages, LabVIEW and C++. WPI Lab offered to do the work for Java along with Sun, and so then there became a 3rd language. Anyway, they're all 3 good choices. C++ is the most powerful of the 3 languages. It's the oldest, most stable. It was written for writing operating systems. If you can't do it in C++, it basically can't be done. Which also means you can shoot as many holes in your feet as you want because it is a power tool, right? Java was originally done for embedded systems, but it's turned into very much a teaching language. It's a teaching tool. It is also used in IT. So again, depending on where your mentorship comes from, you may have people who know C++ or know Java and use it in their day job. LabVIEW is not a general purpose programming tool. It is a programming environment built for engineers that don't want to learn programming syntax but want to control a computer. Much like MATLAB or other engineering tools, it's a fully capable programming tool, but it does not use by as many programmers as the programming languages. So it is specialized towards engineering, has a lot of engineering math and libraries built into it that you can usually get for those other tools. But that is some of the differences you'll see. So if your mentors are engineers who know how to program, they may know MATLAB or LabVIEW. They may know some Java, they may know some C++, depends on where they went to school and when they graduated. If they're an IT person, they've never heard of LabVIEW, but they'll know Java. And if, depending on their age, they may know C++ instead. Right?
Do you know the percentage of numbers?
Or Fortran.
Yes.
What are the percentages of the teams that use those languages? Do you know roughly?
So I do know roughly, LabVIEW is still over 50%. It varies greatly by region. Some regionals will be LabVIEW at 85%, some will be at 25%. I think we actually do surveys on the support forums and stuff like that, and there's actually tracing going in the programs that go back to the FMS. So the FMS knows exactly what language every team is using, unless they've removed that. And, oh man, I'm still having problems with my, hang on. We may have to transition over while I have to remember how to do this.
Okay.
Or if I just, you have LabVIEW on here?
That's Scott's. I have no idea. I don't think I do anymore. I have an SSD and I think I pulled it. Joe has it.
Okay, so unfortunately, you're seeing what happens when you run the virtual machine on my,
wait, did I?
and I hook up to a desktop. It magnifies and everything gets like ginormous. So, what I wanted to do was to show you some of the resources available. I'll start talking about them, or maybe somebody gets like a laptop with LabVIEW would be great if you want to. Yeah, go ahead and bring yours over at some point then. Because what I wanted to show is that not only do you have those tutorials that take you through step by step, but I wanted to show where the environments put a lot of the beginning help. So where you get the tutorials.
I actually have a question about the new version of the RoboRio.
Yes.
So with that, I mean, do you still support 3 languages, or is
Yes.
like actually that's the
The same 3.
okay? But then it's like you have to interface through LabVIEW to Java or C++.
No, that's not true. No. The way the RoboRio works actually is the FPGA is programmed in LabVIEW. It could be programmed in VHDL, but the other languages actually don't work very well for programming hardware like the FPGA. So, but that is closed anyway. Nobody sees that code. That is effectively just part of the robot. So all of the languages, if you drill down, one of the goals when we started was to have multiple languages and to make them as consistent as we could. Terminology, we don't want to call something a widget, they call it a gadget, and they call it a whatever. So we tried to make it to where teams actually could talk to each other, even if they use different languages, and they could actually switch languages. Because in my own opinion, there's a lot of advantage in teams seeing the things done more than one way. I mean, a lot of discussion about wheels and all that kind of stuff. If you want to have a very successful robot in FRC, they're saying very good things. If you want the kids to be exposed to really cool concepts for engineering, there's nothing wrong with making them wheels.
No, absolutely.
Taking them on your robot to the competition, you know, it may affect your performance. But they're a really cool way to start talking about vector math and
I don't have a VGA.
Do you have a mini?
What do you have?
I don't know. It's a new laptop. that
You have
I've never-
HDMI here.
HDMI.
What do you think? You have an HDMI to VGA?
HDMI to VGA.
That's a mini port. Mini HDMI.
You might have it in the magical bag.
Display port.
I've got the mini display, but he doesn't have one on his laptop.
Magical things from China came in yesterday. Including HDMI to VGA. It's like, I know I just ordered one.
Excellent.
Yesterday.
Literally came in
Yeah.
yesterday.
Yeah, you do need that in your back.
Yes, I do.
While we have a slight break, pizza request. Vegetarians? Cheese. But how many? 1, 2, 3 ish. Okay. Other people, any specific do's, don'ts? Nothing, people, normal stuff. Okay, normal stuff. Yeah, I don't plan to go crazy. I order simple pizza for high school students. So.
All right. So back to your question. All of the 3 languages were intentionally built to have a lot of the same terminology and same capabilities. And if you start drilling down, we actually built them in source code. It would have been cheaper for us to just write everything in C++ and just wrap it a little thin Java around and wrap a little thin LabVIEW around, and it would be the same. Nobody would know the difference. But if you have the inquisitive kid who wants to know how things are done, or you need to debug with a kid and go down into the code with them to show them how it works or why it doesn't work, well, now you have the source code. So you actually get to peel away the libraries. And you'll see that the robot drive is built on top of motors, and motors are built on top of PWM, and PWM is built on top of digital, and digital is built on top of basically these chip object things that peek and poke registers to the FPGA. So you can go all the way down to that wall, and below that there's all the circuitry that implements the PWM or the other things like that. And that is opaque. We would happily tell you about it, but we can't expose the source code because you could take out the safety or mess up the safety. And these robots with about 4 and 5 horsepower are actually kind of dangerous. So.
But you provide the API or similar things to
Yep.
that.
Yep. So I will show you that in just a second. Is that the kind of question you were asking?
Yes.
Okay, remind me in a second and I'll drill down in one of those. But the first thing I wanted to do is back up a step and show you one more time where to get some resources. Now I'm going to show you in LabVIEW. There's very similar things like this in Eclipse and in NetBeans. So this is the launch screen. This is the first thing that comes up when you launch LabVIEW. And these little tabs over on the left actually give you direct access to things like the phone number, some of the forums, and some of the manuals, right? So again, if people are getting
Sorry
stuck,
about this.
yes.
For example, if we want to start our team using LabVIEW, and then students need to learn about LabVIEW because they don't learn LabVIEW in school, where they should start? They should start from the robot example, or
That's the kind of stuff I'm showing. I'll get to the tutorials in just a second, but I was starting out for some reason at the bottom and going up.
Sorry.
But that's exactly the kind of stuff I think you should think about. In fact, I was talking about why we did the software the way we did, and a lot of it was to get more of the kids exposed. To be honest, there only needs to be, you'd probably get better code if you had one programmer on every team. But in fact, I've never been to a regional where I didn't have a team that was in trouble, where I ended up writing the code because the programmer didn't get the flu or wasn't there, had something happen. So you want multiple people programming, you want multiple people to know how to drive, you want multiple people, you want some redundancy. And personally, I think computers are here to stay for a while. And I think you want to get most of your kids to think about programming no matter what profession they're going in. If they're going to be an accountant, if they're going to be anything, like a little bit of programming, those concepts are not bad. So getting them all to have some sort of programming task. It can be the scouting report, it can be something else, it can be in Excel. But that's one of the reasons why we try to give some variety here. And so if you want to do some training, and we have a lot of materials, it may be good to do it with a lot of kids. You might find that the quiet girl over in the corner is your actual programmer, but she's not as loud as the boys over here who took Java last year. And you may find out she's a better programmer, or you want to build a team that fixes some of the personality issues. So I would encourage you to cast a wide net and let the kids do different kinds of programming tasks with different languages. We tried to support that. So the next tab, utilities. A lot of the guides, the screen steps will tell you when to use these, but this is where you will end up with a lot of your utility functions for setting up your camera, for setting up your radio, for setting up your whatever. So they're sort of collected here on this page. So if you don't know what they are, that's fine. You may not have to use them, but this is where your toolbox is, right? The utilities for FRC.
So I'm surprised to see you actually have PSOC there. Was that used in the first FRC?
There's actually been, and this is one of the changes to the control system, so that won't be there next year.
Oh.
But there have been these boards that have gone out for 4 years, 5 years. That's from Cypress. It's called the First Touch board, and it was used by teams that wanted additional inputs other than a joystick. So effectively, this is another one of those build-yourself kind of accessories, where the students would then usually put this on another a breakout board, and they would make arcade buttons or knobs that would help affect the robot, right? Or they would make some LEDs that would like show them that they have a ball, or they don't have the ball yet, it's fallen out, or whatever. So that is why this is here. And the way this ships from the factory, it's not programmed with the right image. So this is the tool that would reprogram it if you were going to use it in that way.
And there's several other ways to do that same thing without the board that ships there.
Here's another one that's from TI, and
We used a little Arduino type thing called a Teensy to do it before that does joystick emulation. Anything that can appear as a joystick, you can run as.
Yeah, Crossroad Electronics has the real cheap one. That's a joystick emulator.
Yep. And that's even more true. I'll get to that in a minute because we're not going to do the Cypress anymore. Basically, this was too tedious. A lot of people would mess this up and didn't really succeed in doing it. And
I feel like why it's there, because it's very complicated.
Yeah. Well, even simplifying it down. I mean, it's a nice piece of little hardware, but the fact that it doesn't have an HID personality makes everything else hard. So those are the utilities. Tutorials. So this is yet another place within the product, like on the fly, if you're trying to figure out how to do something, this will take you off to an HTML page that will take you step by step through. Usually it'll tell you to go open up a certain piece of code, and it will tell you what buttons to push and what values to type in so that you can learn about the concept. So this is the list of those concepts that were there last year. And so we have traditionally used this instead of screen steps. So you're not online, you still have it. This is actually in the product. And so for example, this is, I'll open this up, and this is really all part of the same HTML page. But again, you're scrolling down and it's just telling you everything to do to go through. So it tries to,
We can just put in that IP number that you put up there instead of detect your own computer ID.
I think it's a local file, isn't it?
Yeah, it is a local file.
Yeah, so it's just launching that URL is all it's doing. And then this will tell you to do other things in the software. So if you have two monitors, it's even better. And finally, projects. So this is how you usually get started. If you're going to do the training and you get your manual up, yes?
Are you going to show them examples?
I was going to show them examples.
Okay.
So actually, let's do that first. I do too, and that's actually what I had up on my machine. I was ready to show examples, and then the stupid monitor. I forgot that happens. I don't project very often. So one of the things that Joe was pointing out is that there's a thing in LabVIEW called the example finder. And this is one way to open it. You can also go to the help menu, and it says find examples, help find examples. So what it does is it has a bunch of industry examples, and in the center of it, it has FRC robotics specific ones. And these are, I think, really, really good for both testing a robot and also for understanding the mechanisms and the sensors that are in the robot and sort of practicing. So before you get a complicated robot that you start trying to stick this in the middle of and control it and maybe break it, it's really nice to simplify things and build a sandbox, right? So these examples are very good for that. So for example, robot and motor, simple little thing that a lot of people want to do, with motor with encoder. So these examples have a little description over on the side to tell you what's inside. Often the name is enough, but the description may help you pick one. Do you not have full installation?
I thought I did. Oh.
Do they have like trial versions we can?
There are either trial and evaluation versions, and the files are up there. Yeah, it's 30 days, I believe. The last year's key though is indefinite. So if you do get a hold of the 2014 key, which I'm sure you can get access to, it actually lasts forever.
I installed according to the instructions. But this is a new computer, so I hadn't really tried it out.
Yeah.
Everything,
So I'm going to continue showing stuff on his computer, and maybe, I don't know, we'll take a little break or something, and I will try to get the new stuff up on mine, because I want to show you that anyway.
What was wrong with that? Rio didn't show it.
Yeah.
Okay, doesn't have Rio, doesn't have to show it.
No.
Doesn't have the targeting for it.
Yeah, do you have to connect to serial
Yeah, so we're going to have issues with the other stuff too. Okay, so you helped me get past my initial spot, so but we'll have to get back to my computer in a minute. Okay, so yes, the example finder is really good. I'll explain what, I'll show you in a little bit what I was trying to show you. Is that these will actually bring up a panel, which will show you a schematic. And it will show you not only, it's not only just source code, it's not just like a bunch of text, it's not just, code. It also shows you, here's your motor, here's your breakout board. You need the red wire to go here, and you need the black wire to go here. You need to pick your channel number. So it basically will show you a little bit about the real world, and it'll also help tie it into the software. So I think that's one of the better things about the examples, is it sort of relates the real world to your code. And I'll try to show that in a second once we get to the computer that works. So the last thing that you would do on that getting started screen, I did for a test right there, but I'll come back and do it again, is you open up one of these wizards to create your code. So when you return to the product over and over again, you'll often just open up your team's code. It'll be listed in here as one of these. The first time through, what you'll do is you'll actually either construct a dashboard or construct a robot project, right? And so Joe does have, I'm sure, the
Sorry, Windows 8.
yeah, I know. I noticed.
Yeah. Actually, maybe that's a problem.
Now, my stuff it works on it's on there too.
Sometimes I just want DOS, his DOS.
It's DOS.
DOS. It was almost indestructible.
I know, and I just tell my kids at the end, I just want this.
I remember having to go from the DOS prompt to boot menu.
Yeah, I know. All this crap they show on the boot file, and I'm not sure.
Okay. So what I'm launching now are 3 of the other utilities. I'm going to do these things a little out of order. That's because I need to get my computer up on the screen at some point. But for now, what I'll do is I'll go over last year's software for controlling the robot, because there's a lot of stuff in here that would be good for you to be familiar with. Okay. So I mentioned a second ago these robots are rather powerful, and the FPGA is in there for safety. And first, also has documents up there about safety. You should really read through them. And safety is very important, and is a team culture. And the reason you have it here and not in FLL is because in FLL, nobody gets hurt, right? The motors have no torque. Nobody gets hurt in FLL unless they throw things at each other, which happens. But in FRC, these motors, 350 watts is a half horsepower, right? And so when you start putting 3 of these on each wheel, and you've got 6 of these, you've got 3 horses running around inside the room, right? And you've got a high school kid who runs code that's trying to control 3 horses. So, I know, this is what you're in for. So, this is why the FPGA is there, or some drawbridge mechanism, is to basically say that if you want to disable all that code so that code can't influence the electronics, you can do that, right? And that's actually the job of this piece right here. This is called the driver station. And what the driver station does is, it actually keeps the robot, the C-Rio or RoboRio or whatever, in the state that you want it to be in. Because within the user's code, it won't run unless we tell it can run. And even if their code is running and telling the motors to go full speed, forward and backwards and all over the place, they won't do that until you enable them. Okay, and then the user's code is actually being paid attention to. Okay, it's actually affecting their electronics. So the way things work, on the field and in practice and in the pits and in prototypes and things like that, you'll have a computer hooked up to your robot that is basically giving it permission to run. Right? The kids download the code to the robot, and in fact it may be running and it's doing whatever it's supposed to do, but until you enable the electronics, it can't get power to the motors if it's wired correctly. That's the other thing. They can do it incorrectly. I mean, they can touch the motor directly to the battery, but you don't want them doing that. Right? Just for good reasons. So please don't encourage them to do that. Okay, so the driver station is one of those things that will become natural as people use it, and there's a lot of good things in it, but it can be kind of daunting, so I thought I would go through some of the basics, right? And even if you've been using it for a while, there's probably some stuff in there that you didn't notice because these features come in year by year, and so anyway, hopefully there's something in here for everyone. So the driver station, by the way, is changing, so what I'm showing you is not going to be identical to what you'll see in 2015, but it's largely the same. The same features are there. So there's some tabs across the top that have to do with the operation of the robot, diagnosing things on the robot, the setup, the I/O, and this charting function. So one of the things you'll do when you get a new robot or a new computer that you're setting up is you'll come in and you can tell it which team number you are, so it knows which robot to control. Okay, especially over Wi-Fi, you may see multiple robots, and basically you have these things set up so they talk to each other. Even if it's over a cable, the team number is how it finds the robot. Okay, so that's one of the things you'll do. There's other stuff in here having to do with setting up practice matches and setting up joysticks and things like that, which we don't have any hooked in. This window up here is the dashboard. We'll talk about it more later. But basically, this is where you get to some of your choices about how you run a dashboard and which one you use. I'll come back to that later. One of the next really important screens to look at is diagnostics. So diagnostics will actually start to tell you all the devices it found, both Ethernet and USB. And so, in fact, if I take out a joystick, which I happen to have a good number of joysticks in my bags, hopefully your new laptop has joystick ports. Yeah. Or, sorry, they're USB ports, but the kids call them joystick ports. So you'll notice the LED came on saying you've got a joystick. If you've got multiple joysticks, this is how you come over and you flip them around and put them in different orders, right? But, this is one of those things, when I push a button, notice the LED changes color? Yeah, it shows up on the screen. Okay, so you can do basic tests to make sure this is the joystick that you're really using, that it really works. Yeah?
Go back to your setup tab and do the same thing.
Yeah, it changes something there as well.
Right, see how it clicks at it?
Yeah.
So if one joystick has to be number one, that's your drive stick, your driver will toggle that when they get to the driver station, and you can drag them around
Yeah,
to make sure that the driver actually has the drive station.
little
Right,
simple.
And now this is some of the stuff that's changing, so
Oh, okay.
And little simple
Shouldn't
thing
go too deep into
in
this.
general, if you have two Xbox controllers ever, mark one so you know which one is shooter control, because teams don't do that and it's ridiculous.
Yeah.
We've had-
If it doesn't see the joystick, like your joystick comes unplugged during competition, plug it in and hit F1. F1 is the magic key.
Is that going to be,
Recognize your
if that's going to be in the
joystick.
driver station?
Too many people
setting.
don't do
Yeah,
that.
is that going to stay as
Is
enable
that-
still F1?
Not
it is
the-
so far.
Okay. Yeah.
Sorry, is the
En-
joystick-
enables F1, disable is inner. Spacebar is emergency stop. Be
Yeah,
careful,
okay.
never hit spacebar. Unless it uses emergency stop.
Right. And so they're telling you all the shortcut keys because they know them.
Well, it's because it happens so often.
Yeah.
It's useful in the
Yeah.
driver
Is
station.
there a list of the shortcut keys somewhere?
They're on screen steps, I believe.
They're on screen steps, okay.
Yeah. And you don't really need to know them except for what Joe said, which is in the middle of the match, if somebody accidentally knocks them loose and puts it back in, when it's actually running the match, it will detect the joystick.
Disable is one of the most important things to know. Like knowing that you hit inner or spacebar to stop the robot from moving when it's running into somebody is really important. It's one of the first things I teach all of my kids.
Yeah, and actually, to that one, the spacebar is the e-stop for your robot. Yeah, and enter is your disable.
Right, but if you hit
There's
space, so if it's gonna like kill somebody, slap the keyboard as hard as you can, whatever. But if you just need the robot to stop, hit enter. Otherwise, if you hit spacebar, you have to go manually reset the actual Rio somehow. You can't like enter. You can be able to re-enable it from the driver station. If you hit spacebar, you can't. You have to power cycle everything.
And as
But if the robot's going wild,
Hit the space bar.
stopping it is the most important
Correct.
thing.
Yeah.
Absolutely. But if you need to check something, hit enter.
Right. So this X column here is not USB, these are the Ethernet devices, and what this is doing is this is the same thing as pinging the robot or pinging the radio, because what, in reality, you look at these wired up robots, and there's all these things and they're all daisy chained together, and you've got the radio inside here, and maybe there's the field one, and then there's the two things on the robot. And so what this is doing, if this tab is up, or if there's a problem with the robot, it's actually verifying that the device is still there. Because it's crazy how often these things become unpowered. You know, something happened, somebody forgot to plug something in, their homemade cables, it frays, it pulls out, and you know, you come to this page and you go, yeah, your robot out there, that's red. Like, it's not there. So, if that's green, you're talking to the robot. If it's not green, you can't even ping the robot, so there's a problem. So that's what these are here for. This next window over here are error messages that come back from the robot. So these can be as innocuous as, I tried to ping the robot and it wasn't there, or things like that. Or it can be, you just pulled out the joystick, or you just tried to do something in the code that you shouldn't have done and it didn't work. So this is right now on this second tab, this diagnostics tab, and the new driver station is moving to the front page. So, and some of this clutter is going away. So anyway, that's a nice thing to know about, that there really are error messages, and when things aren't working, that's a really good place to go look. This tab in general is a good place to go look. To help troubleshoot it and not just start replacing things or assuming you know what the problem is. So a lot of this, in my opinion, one of the really most valuable things about FRC is kids learning to sort of get a systematic process towards, you know, a complex piece of equipment. And the robot counts. It's a complex piece of equipment. So, you know, sort of teaching them some processes is to like, well, wait a minute, what do you think the problems might be? Okay, let's talk about it and see if you really, okay, yeah, okay, so now go fix it. So. Other things in here, as Alan said, you can actually reboot the robot from here. You can clear the errors out just to sort of see if new ones are coming in, things like that. Again, some of these screens, the details are changing, but generally the diagnostics is a good place to go when something isn't working correctly and you want to figure out what might be happening. Once things are working, you want to drive the robot. This is a good tab to go to. This is where you pick which mode the robot's going to be in. Teleop is first term for teleoperated or tele, or they'll call it different things, but this is where the kids' joysticks actually go straight to the robot and they tend to drive it like an RC car, right? Autonomous is, or hybrid, or whatever they call it sometimes, is where the joysticks actually do not go. You can do this all you want during autonomous. I know they make you stand behind the line, but that information won't be sent anyway. So the joysticks literally won't work, and the robot's supposed to do it itself. Now, sometimes in hybrid mode, they'll sort of let the kids do stuff with the cameras or the whatever, and the robot can get some hints from the driver, but you know, it's less than just driving it around. It's not an RC car. The practice mode is something a lot of teams, if they know about it, they don't use it. So I want to make sure you know about it, encourage you to use it, because this actually goes through the same exact sequence as the field will send your robot through. Many times teams will show up at an event and they go, there's something wrong with the field, it's not working, you know, it hates our robot, it doesn't work on the field, because they've teleopt and they know that their wheels move and they've autonomous and they sit still or they go forward 5 inches or whatever and it works, but they don't work back to back. And that's because there's a problem in the code typically, and that's because they never tested it in practice mode. In practice mode, as much as we can, makes it look just like the field. It sends it through the exact same sequence. So this is a good way to get rid of those surprises. You will find bugs, you know, not every time, but you will find an amazing amount of bugs by saying, go run it through a practice match. I think you'll see the same thing happening. They'll run through a practice match either on blocks or on the ground, and they'll go, what do you know? It happened here too. Now we can debug it. So that's good to know. That's one of the first things that Joe and I tell everybody at events is, well, let's see if it happens in practice mode. Yes?
So this is actually, that will be changed for the upcoming season.
These features are all still there.
I mean, because the practice is highly coupled with the actual field that's going to run.
Not so much. Practice actually does this. What it does is, it does a countdown, right? It lets the robot sit there for a few seconds disabled, and it lets you know. so you can back off or whatever. It does the autonomous, which most years is 15 seconds. This year it was 10 seconds. Then it does a delay. Then it does the teleop, and then it does the end game, which this year was 0 seconds, right? And the end game is really just more teleop, but there's a sound effect, and it's just anyway. And then this is actually lets you turn on or off the sound effect. So this is also good, I think, for drivers. To get used to listening to the cues and thinking about the length of the match and think about where you want your robot to be at a certain point. So this was put here partly for diagnostics, but also partly just let the students practice. And if you want to actually change these numbers and give them less time so that they can you can use this for psychological conditions.
I used to do that with calculator contests.
Yeah.
Before we would go compete, I would actually give them a little bit more time when we would do it, and they'd get a higher score.
Yeah.
So they were ready.
Yeah. So, and you can also use it just to speed up cycles. If you are trying to debug something and it happens right after autonomous, well, you don't have to wait 15 seconds every time. Probably, if you put the autonomous to 1 second, the bug will still happen, and then you can go through more cycles and debug it more quickly. So those numbers are there. That's all practice does. This last mode is called test. Test is a little bit different language to language, but effectively what test does is it actually takes most of the user's code out of the loop, and it says, you're not really running your teleop right now, you're not really running your autonomous right now, you're running your test code. Okay, and not many teams use this well, and that's kind of, I would like to see that change, but this is something we introduced actually after 2012. What test does is, it actually puts your robot in a new mode called test, and it actually starts to show you a lot of the things about your robot. So I'm not connected to a robot right now, but this will actually show you all the motors you have open, the compressor, all the sensors, and all these other things. So you can glance at this table, and it will actually show you if you have, you can actually go up and flip sensors on the robot and verify they work, turn a potentiometer, mess with a gyro or an accelerometer, and you'll actually verify that they work independent of the student's code. Right? Yes?
So you mean the test can actually detect how many sensors, how many filters each team use?
It does, yeah.
That's not
Team.
populated in the other languages yet, is it?
Well, that's why I'm saying they're a little different, yeah. So what this does on LabVIEW is it's actually everything that you open gets added to this table.
So, okay, the team
Right.
does not
And-
need to put their.
Right, and we're going to start doing that more in the other languages as well. Okay, for Java, what it tends to do is it shows you certain objects that you've allocated, like commands and control loops. Right, and it gives you, on Java, it's done in a different thing, but it gives you a place to do. Both of these also give you a way to drive motors or to drive a command on your robot independent of everything else. Right?
You mean the test?
Yeah, test mode. So if I had a motor in here, I can actually select that motor, and then I actually have a safety mechanism. I come down and I set a speed, and I push a button. They're not shown right now because I don't have a motor, and it will drive just that one motor, which is really good to sort of go through your mechanism and find out which one has burned out or has a missing wire or is going the wrong direction. So this lets you also play around. The programmers, before they just write some code with all their assumptions, sometimes it's really nice to know the difference between a 10% input and a 90% input on your mechanism. So this lets them do it before they just write a bunch of constants into the code.
So that's, your teleoperated code could be all messed up, but just so long as the begin and the initialization of all the sensors, that's all the current.
Test will still work, yeah.
So
And
I
that's for all languages?
Again, they are different right now. They're going to become more consistent, but we're not done with that. So I would hope to see test mode support what I'm talking about in all languages, but right now it doesn't. Right now, Java has some features that we don't have, and we have some features that Java doesn't have.
What about C++?
C++ is going to be the same as Java. Yeah. And a lot of this just happens because of the way the development happened. There wasn't enough planning. It was just, hey, let's do a test mode. We had different ideas. They're both good, but we haven't really had time to get them both integrated and have all the superset of the features added back. The other thing test mode lets you do, and this is where there is quite a bit of similarity, is in Java and C++, it will let you send a command to the robot to invoke some code. And in LabVIEW, what it will do is this will list your tests that you've actually added to your code. So this is, again, something most teams don't do. But you can actually put specific test code on your robot. So if you have in queuing, or after a match or before a match, if you want to test out mechanisms or you want to verify the elevator goes up and down, well, yeah, the kids can do it with the joystick every single time with teleop code. You can also write a program that does it, stick it on the robot, and it will run that program. So,
are those
it's just
like
a tool.
Or from the LabVIEW perspective, are those separate VIs within
Yes, they
the
are.
test?
Yep.
Okay.
Yeah, and there's tutorials on how to add tests.
That's neat.
Yeah. And a lot of that stuff was put in, again, because there were robots that broke in 2012 and other things happened, but part of it was you really don't want to see the robots fail when it could have been caught, and so we wanted to promote teams having better test procedures. Verify your robot works before you bring it to the field. And it's just, a lot of times it's super ad hoc. People, again, they're just doing the joystick, they're hitting all the buttons, and some teams are awesome at it, and they find their bugs, and the robot always works, and it's consistent. Other times, what you want to do is you want to write tests and look at this, and that's just part of it's a tool you can use to verify your robot works before you bring it to the field. Speaking of that, I'll stay up here for just 1 minute. I noticed you guys had a checklist taped to your robot. Awesome. You can also put it here if you want to have it done in the software, and so teams can actually double click these as they go down. We talked about whether you should put in initials or whatever you do, but basically we made it to where you can at least have a reminder. So this is the text file. I think it's on the robot, and it pulls it back and displays it. So you can change it to whatever you want to do. All right. So back to the driver station. There's some high-level diagnostics here, and here as well. One of the things that happens on these robots is it's battery powered, and so if the robot battery is dropping and gets too low, the robot starts acting flaky, and then more flaky, and then pretty soon it stops working. And sometimes people don't really pay attention to that. Anyway, one of the things that's top center, is the voltage. If you have a 9-volt battery, that's low. It should actually be 12.5 or 13 volts when it's sitting still. So a lot of times, especially newer teams, they won't realize that. They'll go home, they'll come in the next day, they're doing things the same way. It's not behaving the same way. They have their battery is way low and they don't realize it, and the robot reboots and they blame the programmers and all that stuff happens.
That's one thing you can put on the checklist, make sure you have a full battery.
That's correct. So this communications light is an overall communication. This basically means everything is working for the robot. Like the field is working, the rodeos are working, everything's working, we're in communication with the robot. This next one means that your code is still running and is doing the thing that lets us know it's running. Okay, so sometimes code stops running, especially in C++, but sometimes even in LabVIEW and Java. And this, it's really mysterious. My robot's not working anymore. You don't have a monitor attached, so this is effectively your way of knowing that your program's still running, right? Or that you've never started it. That's even more common. People forget to download code to the robot. Why isn't it working? Well, you didn't put the code down on the robot, or you didn't do it in the right way. So that's why there's a red light there for that. And finally, when you pull out the joysticks, there's another red light for that. And we don't know the difference between having 3 joysticks and having 1. We don't know how many you really wanted to have. But if you have 0, that's a bad number. So that's what the red light means. There used to be a Connect supported. That's actually one of the changes for the new system. Is we think those are pretty old. They're not getting new donations. So we're no longer going to have this Connect stuff in here. So I won't talk about it unless you make me. The battery, this is a part of your robot. If teams go to the field and their driver station laptop dies because they didn't plug it in the pits and the battery dies in the middle of the match, the robot will stop running.
There is now a port on the driver station, finally.
Yeah.
So
there's a plug at the driver station where you can plug in your laptop.
They gotta bring the power cord.
They gotta bring
your
the
power cord.
in.
But be thankful it's there. This was the first season it was there.
Yeah, so that's why this is there to sort of help remind them. And part of this is because a lot of times this is full screen, and you may cover up this stuff and they may not realize that their laptop is down to 10%. And as you mentioned, they've got 6 matches. They got everything went right. You're in the finals, whatever, and then your laptop battery is almost dead.
And that has happened before, finals, eliminations, and all of a sudden.
Yeah. Let's
What a
see.
good idea to plug in your laptop over lunch.
Yeah, plug it in when
Even though the driver station has
ours,
power.
whenever it's in the pit, it's plugged in. In general, brief driver station laptop stuff. Make sure before you go to an event that all of the updates are on. Turn off like some of the hibernate sleep modes. We had a long delay once, and somebody's driver station went to sleep while at the driver station. That was fun.
Turn off your antivirus. On
Yeah,
your
all
laptop.
sorts. The laptop should be. It's not going to be on the internet. Have it ready to go. You don't want Windows Update coming in the middle of the match deciding to restart your computer. Like it's not. Yeah, there's lots of weird things that can happen when running a Windows PC as part of a robot.
And teams have had problems with antivirus. All of a sudden, my robot's sluggish.
Yeah.
Then you go back. Oh,
Yeah, all sorts of weird services. Somebody in your team should be in charge of keeping that up to date. You're running all the NI, software updates, getting all of that working.
Okay, this I/O tab is there in large part because of the Cypress board. And some teams had a ton of fun with this. There were teams that built their own joystick, that built their own thing they strapped on and drove the robot with on this arm, and it was really cool. So there's a reason why this was added, and it's to allow creativity and allow teams to sort of think out of the box. But this screen and the Cypress stuff is largely being replaced with other devices that pretend to be a joystick. So really the teams can still do a lot of the same things, but they will do it on this other tab instead of on.
a lot of people will use this screen for autonomous.
Yeah.
They'll have like 3 or 4 spots to set up the robot, and they'll just set a button on this screen when they set it up.
Right. So this screen's not here anymore though.
Oh, it's not?
No. This is going to be moving up to the dashboard.
Okay.
Because you can really do about the same stuff up in the dashboard by setting these sorts of sliders.
Yeah.
Or these sorts of checkboxes to say, do I go over the line or do I shoot the ball or whatever. So these are the sorts of things that you can set here and your robot can read them.
Right, and
And
Java
because those
C++,
are there now.
we have Smart Dashboard as well,
Right.
which does the same thing with little text box and stuff.
Right. And because those are there now, we don't really see the need for this as much. And so a lot of this is being simplified. Right? We may add some stuff back. There may be a really cool product that comes out 2 years from now that's just awesome. They plug in their cell phone, and I don't know. But for now, we're simplifying a little bit so we have room for some more stuff. Because this, I'll just show you real quick. This got crazy complicated. You could go to the enhanced mode for the Cypress, and you could set all kinds of stuff, and you got like a bajillion things, including accelerometers and all on that. Well, actually, this little bitty board, and it was way overdone. Very few people use this stuff. So
you said, what tab was it that you can go and click a button to change your autonomous modes or whatever? Those in?
it'll be done a little differently. There's actually 2 dashboard choices out there. Actually, there's more, but this is what we refer to as the smart dashboard. This is the binary one that you don't even have to write code for. That gets installed. There's a project that will give you the source to this. Java has 2 different smart dashboard implementations. I don't know what they're going to do about which ones they're going to keep and
I
everything.
haven't seen many people use the FX one yet. That was just came out.
Right, and so effectively though what all of these are doing is they're giving a graphic element to a shared network piece, right?
Okay.
So you have a piece of data that's shared across the network that I can either set here and read on the robot, or the robot can set it and I can read it here. So this is useful for, again, intake mechanism, is the ball there or not? Or, gee, do I want to run it 40% or 30% on my intake roller?
Yeah.
Or anything else, right? I mean, you could drive the robot with this if you wanted. You don't have to use a joystick, but I wouldn't recommend it.
Yeah, we use it for we have a pressure transducer that tells the driver what the PSI is of the robot in nice big letters. We change every state, mode, speed, times of different things, all sorts of stuff like that can be changed on the smart dashboard.
Do you know if you have any log files up here?
I don't think so.
Okay, except for the All right.
I can get logs.
If I get my laptop up in a second, I can.
Yeah, I can give you logs too.
But I was going to show you this last tab, and this is starting to get pretty advanced. This is something that teams can use during a match. We use it all the time as CSAs, but this was added at some point to give us better diagnostic of what's going on in the robot. So this is effectively like,
Say what a CSA is.
Oh, sorry. Yeah, CSA is a Control Systems Advisor. So this whole thing is called the Control Systems, sort of all the electronic stuff. And effectively, since it's a complicated robot, and at the event you want everybody to succeed, and actually drive on the field and troubleshoot more quickly, there's usually people there to help. In reality, every mentor, most of the students will help you if you ask, right? It's a very friendly environment. But there are people who are specifically trained to help troubleshoot and do it. And we wear orange hats for some reason, so we're easy to find. And so if you do have a problem with your robot, usually an inspector or the CSA are a very good place to start.
Or the trained CSA.
Say, hey, we don't know why our robot is not running, and we have a match for 30 minutes, help us. And they will. So this is one of those tabs where it does the basics. It tells you on your robot that doesn't have a monitor attached, right? Well, how much RAM do I have left, and how much disk do I have left? Did I use it all up? Is my CPU pegged or not? You know, things like that. Yeah, exactly. It happens. And then there's these charts which show a couple of additional very important, 4 additional very important features of your robot. One of them is the voltage. So you can't see the yellow line on here because I don't have a real robot. But you know, in a normal match, this actually shows you what's going on with your battery. And if a battery actually does charge well, but is old and doesn't hold a charge for long, you'll actually see this decrease over the match. And you'll see, yeah, you turned off a minute and a half into the match because your battery really did drain all the way to where it couldn't run the robot anymore. You'll also be able to see, in fact, it's really fascinating to see, you can see motors going on and off, especially these spinners with these flywheels. You'll actually see them, you know, a nice consistent little pattern, and then every time they shoot a ball, you can tell. It's kind of weird, you know, it's like a heartbeat, but you can see what's going on the robots to a large degree, just with the voltage. Second line that's on here is the CPU. So that's the same thing for your student's code. If that's at 100% all the time, well, you know, the robot will probably continue to work. But it means that they probably need to think about why that's happening, because they are using the CPU all the time, 100% of the time. They are probably not reacting to things as fast as they think they are because the CPU has no additional resources available, right? It can't respond to what they're doing.
It'll be laggy.
Yeah, it'll lag.
It's normally a pretty small error too. It's not.
Yeah.
It's just
Usually
a process running all the time.
They forgot to sleep somewhere. They forgot to wait or sleep or delay, or they forgot to wait for something to happen.
This line shows like 0% or something.
Well, yeah, I don't have a robot. Yeah.
Oh, okay.
If you want if you want log files, there's a log files folder on there. That's a bunch.
Your USB safe.
As safe as they get.
I don't know. We do have a robot. That's still
It wants to scan your drive. Let's not do that now.
I mean, you could just.
It did.
It automatically wants to scan.
Yeah, it wants to
Okay.
scan everything. Yeah, because at some point it was removed without hitting reject. PCs
Well,
are.
I mean that's a new one that it's never seen before. So and I'll go ahead and trust it for some reason.
There's a log files folder somewhere on there.
All right. Well, normally these are going to be.
Well, it's gonna get scanned.
What's that? Do you know where the log files are?
It's a log files folder on there.
Right
Log
there,
files.
log files.
Yeah, that one. That's just the straight.
So stick that on Joe's desktop in there.
80 megs. It's a lot of fun. It's a lot of log files.
Fill up all of Joe's 20
Sorry, you let me borrow your laptop. This.
Joe.
A whopping 80 meg.
Well, that's okay. I have a few gigs of them on mine. So.
It's just
No,
a
I'm saying it's
desktop
not.
thing. Yeah. Well, I don't know.
Some of them are obviously brand new.
Okay, so this is what they're going to look like. This thing I just opened up, by the way, is called the log file viewer. So this is really just a bigger version of that little thing that I had a second ago. Okay, and I'll explain the last two things on here as soon as we find one that's interesting.
Does it automatically name them?
It does. It does. And it will name them the same as your laptop's clock. So it is really common for them to be off by days, hours, time zones, and all kinds of
So
other
yeah,
things.
Please set your laptop clock properly, even
Got
on
one
one
from
driver's seat.
1974.
One warning is if you're using a school laptop and you're not logged in as administrator, sometimes it won't save things because it's in a area that it can't save it. And so I've seen it where everything's in it.
That's a
they
fun
don't have
one.
privileges enough to save it.
Did you get your voltage?
Do you think you have some matches on here?
I'm sure they do.
Ooh, on there won't be anything that's run as a straight match. Probably. This was never FMS connected.
This kind of looks like one.
There's
I'll go
matches,
here.
but nothing FMS connected.
Okay, so I know this is just a bunch of squiggles on a graph, right? So let's, again, I'll try to help you understand the little heart monitor for the robot.
Make it wider.
Wider? Yeah. Okay.
Oh, and there's that
So
one.
ignore that stupid button that's over the top of it. That's a bug.
Wait, did y'all fix that?
I will fix it, yes.
It's not fixed yet.
I know who to talk to fix that. Close. So what these squiggles mean, they're the same colors as they were in the other one. So the yellow one is your battery voltage. So as I said, you can tell the difference between the robot sitting still and the robot actually driving, and people sitting still on the field and driving. And I mean, you guys don't have any spinners this year, but this is the kind of thing that you'll see. Notice the battery voltage down here getting under 6 volts, all the way down to 5 1/4 volts at the very end of like 8 minutes. Yeah.
If it drops below 7 or 8 volts, we don't guarantee that.
Yeah. So basically, this is the kind of stuff you see. It's like, and when they are driving, but like sometimes when they let go, it's not going all the way back up to 12 anymore, right? So when they're sitting still, it's not going back up to 12. So this is just like your little battery gauge in your car, only a lot more detailed. This is their CPUs. They're starting out running one routine. They enable the robot in teleop. They're running another routine. They enable the robot over here in autonomous. They're running another routine. So you get to see what the CPU is doing for different things on the robot. Again, if it goes to 0, that's not good. If it goes to 100, that's not good for very long. And so this is the kind of stuff that you would see periodically. They've got something going off that's actually dropping down. Nothing concerning. It just gives you a little insight into what's going on in a robot that may help you understand the behavior or the behavior of the code and relate those things. And again, these are good things to ask the students about. Well, why is it doing that? Can you explain that? And it's their thing, And then if not, well, let's go figure it out. It's a little puzzle. So these other two plots, the green one is your time that it takes for the laptop to send a message to the robot and get a response. So this is basically the little conversation they're constantly having about the joysticks and the battery voltage, for example. This will take the joystick, put it in a packet, send it to the robot. The robot will put the battery voltage and the CPU and stuff like that back in a packet and send it back to the laptop. We'll time how long that takes, and this is only a few milliseconds. So it's a very quick little conversation, and that's kind of what you want to see. That's very low lag. Don't know if you knew this, but your laptop, or whoever's laptop
has the
is
1
doing
minute
this,
spikes.
is about every couple of minutes.
That's
you have
a
you
1
have a
minute
glitch.
spike.
That's all. That's when we were practicing at 118. So there's all sorts of interesting things that happen
Right.
with lots of
So-
robots.
Yeah.
Well, it's not
So-
118. It's just that there's 8 robots all running on the field, and we're doing all sorts of weird things with the network.
You have the 1
So
minute
your
spike.
glitch is, so you click on this and you can zoom in. Your glitch is 69 seconds. And it's glitched for about, I would guess, 4 or 5 seconds. So yours is not the first laptop I've seen this. So basically what I'm looking at here are this spike in the green and this spike in the blue. The blue, I hadn't explained yet, is actually the lost packets. So there's those packets going over, right? And there's a total of 50 of them per second, right? So 50 times a second, the joystick gets sent to the robot, and the robot sends some diagnostics back. That's when it's working correctly. If something happens on the way to the robot, or something happens on the way back to the robot from the robot, it's considered lost. And it just goes in a counter that says, one didn't make it, right? And you'll see that most of the time, everything's good and they make it. When things get noisy, I mean, this is a wireless environment, right? So you've got other things that can happen. You'll see little losses and stuff like that. That's why we send 50, right? If one doesn't get through, well, then maybe the next one will, right? Well, when you have a period like this where almost none of them are making through, because this is actually a half-second measurement that we report this on, so the robots are going to be pretty glitchy right there. You guys may or may not have even noticed. Turns out in reality, a lot of these robots have a lot of momentum. So if you try to shift position really quick, and it doesn't, it can't respond quick enough. And so a lot of times teams won't even know this is going on. So some of the drivers will know, some will not know.
We do when we're down when you get a bunch of robots practicing together, especially at the NASA facility at 118, is a Wi-Fi horrible zone. So one of the reasons we use off this is it has 5 gig, that one doesn't. So we do a lot of stuff to get it even close to working half the time.
Yeah, well, in fact, I'll talk to you about this later because we're trying to figure out things to do to laptops to make this less common. Because Joe Ross is seeing this right now. That's why I knew it was 69
It'll
seconds.
be interesting to see if it's there or if it's their venue, because that venue's a mess. Like, we can pull logs some other time.
So anyway, that's the kind of stuff that you can do. Notice there's other little stuff over here. If you're connected to a real field, it will tell you which match you ran. It'll tell you when your computer disconnects, when it reconnects, and how many times that happened. And there's a lot of stuff that's logged automatically just when your laptop connects to the robot. So not everything. It's always good to write your own logs. You were having a conversation at dinner last night. You know, if your programmer wants to know, you know, I don't know, if the pot ever goes all the way around 3 times or whatever, this will not tell them that. They'll need to write that themselves. And how do they know after the match when they turn off the power on the robot? Well, it has a hard drive. So store it to the hard drive and pull it back like this and build a little display or a text file or Excel or something like that to pull it back out and read it. So that's actually one of the things that makes me the most happy about being an FRC is when teams actually know how the robots work and they can prove it. And it's not just a bunch of speculation, but they can actually have data to back up their claims about, you know, their Wi-Fi not working or their CPU being overloaded or whatever, or their, you know, their motor didn't turn off. Is they have data to show it. So we do some of that for them. They have to do some of it themselves.
Show the event list.
Yes.
Show the event list.
Yes. Good idea. Okay, and there's this clean, but this is actually where, if I just turn on all events, I think I'll be able to show a little bit. Yeah. This is where these little markers on the graph will just be listed in a different direction, different way. So notice these little bitty markers here. If I hover over this, it tells me my radio was seen at 6:56:02. And if I hover over this one, this tells me that it pinged the robot and this was the response. And over here, you know, this was the driver station communication was lost and a couple of other things over here. So these little circles up here in this zone give you these events and correlate it to everything else happening on your robot. So sometimes it's really nice to know when that event happened. Other times you just want to read a list and you want to look down the list for a specific thing. So this is a different view of that. Yellow things are warnings, probably not anything bad. And the red things or orange or whatever the other color they are more errors. So anything else that you guys use that you wanted me to show?
The match length, right now it sets the width of the display when it doesn't start.
Yeah.
At the start of tele or at the start of autonomous.
That is
It'd
correct.
be really nice if it auto positioned in time to the start of tele or start of autonomous and then the width of the match. Because you sit there, or at least I have to slide it back and forth and it never works.
Ah, okay.
That's my problem, not the machines.
Sure. Well, yeah, the point is there's a couple of little buttons over here. You notice I zoomed in a minute ago. Well, how do I zoom out? Well, it turns out there's ways of doing it with shift keys and stuff like that. The easiest way is to hit the auto scale button. Or he was mentioning that this is actually a lot of data, right? So sometimes it's useful to only look at, you only care about what happened during the match. And you then scroll over and you'll see, some green, some gray, and some blue, and that'll be your match. Everything before it and after, it was just a robot sitting on the field. So sometimes this is all you care about. So, I don't think there's really that many more features in this.
No, but this is an invaluable tool. This is really, really nice.
This is what a lot of the CSAs, like you said, looks at whenever they try to diagnose the problem.
Okay.
It's good to learn.
So I wanted to show you some of the new stuff, but I do need to get my laptop connected. So, do we want to take a quick break and let me do that, or you guys want to talk? Do you want to say some things, Joe, while I try to get my laptop working? So in case you didn't know, Joe is a field, he's an FTA and a CSA and a whole bunch of other stuff. And he knows
All we can do real quick for transition is my guys brought by our robot. And
That'd be good.
Let people just take a look at it and they can ask whatever questions they want about it.
If we can do that, and I'm also going to, really quickly, I'll project the Java and C++ version of the smart dashboard as well, so we can see what that looks like.
So if you want to join us out in the hallway, part of our break, Come on out. Come on out.
Let's funnel out to the
Follow
hallway.
me. Follow me.
We're gonna go see Texas Torx Robot.
So I actually need a cable plugged in order to right?
See if I can. Yeah, no, that's fine. I'm just trying to figure out if it'll actually work.
That's kind of a
So I don't know if I'm not gonna be able to.
But it's one less thing to buy.
Well, see, where we have someone to use.
Right.
And then there's that down area.
This is what comes with our kit, right?
You get a classmate, yes. So I don't know if you're gonna get next year. No idea.
Okay,
But
so
you'll
I'm
you'll most
assuming-
likely get a laptop of some kind.
Okay. And then you guys use this, or you
We
use a
use it.
different laptop?
We use it. Most teams don't.
We use it.
at We use it
Before
on.
we should use it, right?
Actually, a really high percentage of teams do.
Yeah, it works well. It's a small form factor. We don't want to use a nice expensive laptop that it only does that. We
Yeah.
don't do any development on it. We don't do anything else. It
Right.
runs the driver's station. It's a horrible computer, but it does what it's supposed to do.
It's an Intel Atom duct tape to a 32 gig flash drive.
Show me the Java dashboard.
Yeah, it's right there.
But it does
on
do
this one. I couldn't get
Or do you know, Alan,
So this
has
is
that
a
key code if we needed to get
over
it
many
this
years of us
year?
doing like
the
this
last
whole
few,
season.
yeah, actually, I have it on
remember
there.
not cleaning
Do you
up like you
think I
should,
could
but you can literally.
It's on the flash
So it gets, and I need to step out for.
Okay. Well, maybe could you like
Yeah, I
bring it up?
It has.
Yeah, I can get you the key.
Okay. Thank you.
But it is sitting. We had.
And I tried to
Okay, because I just thought it might take.
So the driver station is the same. The bottom part.
Yeah,
The dashboard is different. So that's all.
Ridiculously small.
So you can basically, in code, you tell it what you're going to send back. So what's on the robot actually tells it what's going to be sent to here. And you can send variables. You can also, at the beginning of your code, send a blank variable basically, and then you can have it as an input field here. And you can input whatever you want. So we'll say what autonomous mode we want to run. We have a list of like 9. You can select from 0 to 9, whatever. We can set different speeds here, all that kind of stuff. We can also have it report things back, so every cycle it can update.
So
we
it can do the same test functions as far as testing specific motors.
It does commands. It does it at the command level.
Right.
It
So you
should
could
do it
write
at the
test
motors.
commands.
But right now, Java doesn't know. It doesn't have a name for all the motors you've opened yet. So we're going to try to fix that.
It's a really cool feature that we don't have right now, but we have it where we can we tell it what speed certain buttons set the motors to. When we can set the speed, then you hit the button normal. We don't really use the test mode right now. It's something we definitely are going to look into. We just haven't gotten that far. But yeah, we can do things like change text size and stuff easily, which we actually didn't know you could do for a long time, but it's relatively easy to do that. You can graph things nicely, which is really useful. So when we're doing robot tuning stuff, we can very quickly see RPM graphs against different things. And
Abbreviated saying it's nothing like.
you can pull variables and log stuff.
Pretty similar. Okay.
It's pretty good.
Do you know what it looks like?
Succeeding in getting some. So and I'm actual. How much have you?
Sure, it's about 11:30. Theory pizza's here, but that's not good. So it'll run lunch. After lunch will be a lot more non-technical.
Well, I've already explained most of the things.
Yeah, it's kind of new.
Yeah, I'll just show that it's different, and I'll just show the libraries real quick. Cool. Just the new libraries.
That's perfect. And then that should either take us to pizza or we'll be able to answer some other questions.
Do you want to talk about the net console at all, or is that a bit too?
I think we can avoid that.
I wasn't going to talk about the net console. In fact, now that people have SSH and things like that,
I've used it all of like never. So
I used it a lot this summer.
In 2012, only because we were using C++, we know how to get information out.
we can throw everything to Smart Dashboard and we just don't even.
Smart dashboard is nice.
Unless it has bugs, which C++ I did this year.
It did. Because wasn't it like if you disconnected in the middle of a packet? What?
Bearing bore on the inside of how do you even do that? Honestly, these rules it's like you got like a storage container or something.
Yeah, they probably actually.
I know.
The last time
So mine doesn't even have an Ethernet. And you're kind of like, seriously, you're building a laptop with Ethernet?
I know, that's
So I had
really
to,
weird.
I had to buy. I mean, I knew it, but I was really worried about it. So I went to the store and everything, and you have to buy this.
So why is that in heaven?
Because Wi-Fi is awesome. And in fact, unless I'm doing the robot, I never use a cable. But when I want to do the robot,
Oh, see, I use lots of times I just don't want.
I know. And it's faster to do cables and all that. I mean, but you know, the typical consumer, the typical person that's going to.
Well, see, I allowed myself to get Windows 8 just because this is like a this is more of my first kind of computer. My real one has like Linux on it, two flavors, and then
Well, that's what I was really gonna, that's what I was
Windows 7.
currently.
Well, I've noticed that included Windows 7 as well.
Yeah, I made myself get Windows 8 on my work machine so that I would realize the pain. Oh, sorry. That's
I like that little box.
And appreciate every other operating system a little bit more.
Yeah, I figured, you know, I'm gonna stop supporting Windows 7 for some time, although I know corporations and stuff.
It'll be another 6 years or so. I mean, people run manufacturing on our stuff, right?
Yeah.
So the XP transition, I mean, they just basically have to
I guess my question is
streaming, and they may even have contracts with certain companies. I know whenever we do these big things, we have to put our code in escrow.
We're gonna see how good.
So you have this. There are support contracts you can get.
Once we win.
Oh yeah, for sure. Well, I just looked at a pressure tester we had in Camden, and it was something, some company that apparently the only guy who knew about it left. It's an LabVIEW. It's on XP, but now they can't do anything. You know, they have to make sure this one computer keeps going. So we don't have the money yet, but I think I'm going to be asked to redo it in something where we can actually support it.
Is the new
I'll learn
so much better than the old that really takes away some.
What do these buttons?
The biggest thing is
What do they do?
This button restarts.
Yeah, right. The new one doesn't.
It's
Yeah, it's not.
reset the application, which is pretty
Because
far.
you got like
This is a button that you can use to cycle through things.
That was the big code, and then
Okay.
because you can.
Yeah, probably for like, you know,
Nobody will use it.
No, of course
Oh,
not.
I can see people using it.
I think we have it on the MyRio, which is mine too.
Okay. Because it seems like you just kind of took a Rio and reworked it.
Most people won't use it.
Those three things are basically done by any art if you want to, right?
The
So
Luke's
you
going.
can buy some.
So we do code, like, do the
And
affinity
then the wheel change.
processor affinity and all that stuff.
It doesn't work quite as well on Linux as it does on VxWorks. You can do affinity about 98% of the time. What happens is there's certain service tasks that Linux wants to run, even though you have affinity set on a project processor. So more or less, but it's not quite as hard real time as VxWorks. Those are
But like, if we have something that we know is gonna be Activision or whatever, you can put it on
Yeah.
processor 0 or part 1.
Well, that and you know, if your things can't take more than one processor anyway, if they're like single threaded, you often don't even worry about that. A lot of
Yeah,
times
but
it's the
anything-
overhead of the context switches. You don't really want the OS doing that,
Right.
but it'll do it every 5 milliseconds if you don't, or if you aren't careful. And so a lot of times that's one of the reasons you do the affinity is to reserve some resources so that there's less latency, or just to say stop doing that. Your overhead is something I don't want. Because they'll just rotate as if they're going to wear out a CPU. They'll just like, here, your turn, here, your turn, here, your turn.
I mean,
We just ran into a problem
you
where
look at it, but
we have
you look at it and
yet
go, I don't know
another
how to
really
do
old
that
piece of code,
here.
really old card, really old drivers.
I would love for.
So when data comes in, it comes in, and if you don't get it within, you know, a millisecond, it's gone. So we had to set all that stuff with affinity on another processor because the OS kept coming in and keeping us from parsing it.
Or change the dimension. Oh yeah, it's not. They get themselves in a giant
The only
mess
modification I'm a big fan of, and I think more team need to realize we can do because it's awesome, is you can take the kit mod. So normally you have either long, right, 6-wheel, blah blah blah, or you fly. You you can take this kit bot and you can make square by doing offset wheels. So these two are closer than that one.
Oh, yeah.
So you use the wide belt on the back and the long belt on the front, and you get a 28 by 28 robot. And you always are basically on these four, but you tip on those two when you need to. And you get a nice square platform that a ton of teams built this year.
I saw this.
Yeah, there were a couple teams who did it, but not nearly as many did it that closely. Especially, and this is a very useful year for it because basically at 28 by 28, you can fit a 24-inch ball inside the robot perfectly. It works. Which is why most teams went
But I
28 by
did see
28.
several teams
But not
do it.
not enough teams did it. But there were a ton of teams who
I was
could have
kind of
done
just
it and
saying
ran
Grace
a great deal
Grace
on it.
But this is gonna be, do you think this is gonna be a game specific?
Yes, it's very game specific, but it's one of those ones that Amar doesn't.
I just pulled out my very
This
first
year
robot I
changed
built.
everything.
And
Any of
refitted
the
for Arduino,
robot
like a
3A's
basic
done it,
stamp processor.
closer to like 50.
And I don't know if I can have the program on a
because the
floppy,
whole ball inside of it, like it was a
but I don't
huge deal to do the whole ball on all four sides.
Yeah.
Do you
But
need
they
it?
just didn't realize. you could
Well,
do it with a
nah,
chassis.
so I was gonna move to Arduino and
You kind of just need to
Yeah,
know,
you're welcome.
Mick,
I'm a,
But you might
just
know
need to know
what
what it was
the
doing.
team's not.
So
You
you
can
look
look
at
at
it,
the kit
yeah.
bot, but maybe not.
no, I don't know.
modify it, yeah.
It was really,
Modified.
that reminded
And that
me,
was really
it was
my-
a
That-
steering
completely
robot.
understandable.
that had a
Behind the
servo,
question
right?
is somebody working
So,
on it?
Yeah, it's
I thought, hey,
something I would like to do. I don't remember
I
where.
know,
We have a belt.
going
Oh no, we don't have a
through
belt.
robotics
We have the
lab
first belt
over
one that was on
Woodlands.
C-base. We don't
We were
have
just
the
going
new
through
one. We
stuff
don't have
and
the
the
sheet
rep's
metal
like,
one.
hey, you want this? Throws it to me.
But I don't really know.
It's a floppy
I
disk.
guess my
With the
underlying
with
question
the,
is,
the basic
is there-
step code you
is
would
there
need
as
to
much
flash
point to doing that
1997
as there
operator
was
interface
before?
No.
first.
And that's really
You don't gain nearly as much advantage as you
Somebody
did
gave
from
me
the old
no
C-base to
control
the
system.
like the old one you had.
I like the old
There was a
iPhone.
huge reason to make
It's-
it drastically better. This
Yeah,
one,
yeah.
Andy Mark
It works
fixed
well.
many
Well,
of the issues.
assuming
They
your
added new
controls
ones
aren't
like
fired, so
the
at
whole
which point
you have flat rails and how do you mount those because it's really impossible and bumpers are terrible. Like the fact that they broke bumpers was really annoying to me, but kit mount bumpers suck. Like if you don't do a full square, the kit mount mounting bumpers in the kit mount is terrible because they have flat planes.
We had
And
bumpers
then they
break
sell like
this year.
oh and we broke bumpers too. Well, no, but they broke
Yeah.
bumpers in the fact that it's hard to mount them. Like you can't just take
I mean, going
four
to-
pieces of plywood with like pullers around them
Oh,
and mount them
oh,
each side.
yeah.
Like you can buy their really specialty bracket things that have the little jogs in them that like cut up over the lip, but it's like that's not right. It's really weird.
Show them this. Show them
They should have figured out a way to put a flange on every outside lip. But the front and back just have a flat wall that you can't mount bumpers to. So you like
Yeah.
they broke how people normally just make bumpers. Like you could make bumpers in an hour if with a couple
Yep.
pieces of L aluminum,
I
right?
don't,
Now
I
you
don't,
can't.
I don't know that
And
the stuff
it's
on the
really
screen
annoying.
steps
Well, it
is
was
as
always
good as
a pain
this.
to
This is
mount
actually what Doug's
bumpers
been
to
takes
that
his time.
C channel.
But you could at least take an L, put it on top of the C channel, and run a
okay.
bolt through it, and it would work. It wasn't good,
But
and it
Brad
would take
used to
forever to
do this
change,
kind
and
of
there were
stuff.
lots of bad problems with it, but at least it would work. Right now, you can't even do that. The front is literally just a flat plane that you have to figure out what you have to do. You have to put a stub
that guy,
through,
okay.
or
That's what I
make
saw a lot of
You've seen it.
full square.
Yeah,
Like
I've
for most
talked to
routines,
him.
we recommend just making the full square
names very well.
and have two
That's
sets of
just
it
all
because
the
that works
technical
well.
people know
But
all of the other
it's a lot harder to do.
But for a rookie team,
Or
I don't
you just
know.
know
Yeah, full square is hard
No,
to do. Like, we
I
did it
don't know,
early for them, but
actually.
at events, it was
I don't
really
know a lot
difficult.
of people. I don't know most people.
Which is where you
But,
find the teams
I do
who
like
show
this
up
part.
and think they can build
Big
it off in
example.
30 minutes.
Is you can show kid.
Or like at Alamo
Get 'em to
when
do
we
something,
literally pulled
and then
plywood from the
work on
dumpster.
moving it from
Yes.
here.
That's-
Oh, yes, there's a whole lot of
That's my
plywood out of
favorite
that
story.
dumpster.
we literally, I can't believe no one had bumper wood at Alamo. That was so ridiculous.
What?
No one had bumper wood at Alamo.
Well,
so we
it's the
literally
same thing
pulled bumper wood from a dumpster. We found a 3/4 inch pallet that was in a dumpster, and we had a team pull it out, like pull stuff off of it, and use it as bumper wood.
At Lubbock, the Chinese teams had to have their robot shipped.
Took the crate apart.
Their crate was their bumper wood, and they shipped it back in their suitcases.
Yeah, they took it all apart and packed it in their suitcases, which is really ridiculous.
Well,
It saved them a lot of shipping costs, I imagine.
Brazil, apparently, I talked to a lady from Brazil, and she said that to get stuff into Brazil, if it costs over a certain amount, it's like a 500%
Import tax or something.
some kind of tax that.
Tariff.
And so what they do is they take apart their robot, and every kid, puts in
Takes
less than
these.
this much worth of stuff in their suitcase, and so they never come back with the working robot. That's kind of. She said that it was like their next year's project to put together. The kids during the fall put together the old robots, to learn.
It's crazy.
For the next.
Yeah, it's so much harder to be a first team internationally. Like they wonder why it doesn't spread, and it's impossible to do it. I
The
mean,
cost and the
like,
difficulty.
The Netherlands
shipping
team, I
and
think
all.
they spend $140,000 a year to
Yeah,
be able to get
that's-
over here and
that's-
stuff.
that's right.
I mean, just
That's-
team budget is literally $100,000 over what we're spending in the
And
States.
she was saying that for first Lego League, even people in the Amazon were traveling like 3 days to an event, by boat.
In a dugout canoe, practically.
That's what they do anyway, though. Is actually one of the cute photos I took. So we went down into Honduras.
Yeah.
And they have a yellow boat that's their school bus. And it goes around the canals and picks up the
It's
kids
cool
and
they got
takes
it
them
to
to a
be
building.
yellow. That's interesting.
I know. They have,
Why they get it? I'm just wondering where that
They painted it yellow, exactly. It's so
But I'm
you
wondering
know
if
it's
it's
kids in
because, was it because
just
like
community
we've seen
thing.
other school buses, or is like
No.
yellow just because is there something that associates yellow with
and
school?
they're a fishing village, so but there are other buses, other places on the island, but yeah, so they know what a school bus is. They just don't have one. They have a school boat.
Okay, I got
and, and it's yellow, and that's what the kids go in.
It's
But
amazing.
people know to slow down. Don't knock the kids' boat over. It's full of kids.
It's amazing, what some people will do just for education. It's like great.
Yeah.
Oh, did you ever get that Honduras, that one church or whatever going?
I need to contact the guy again. I need to get somebody else to contact him, I think. Yeah, so this is
Would
a
it-
weird story.
Would it help if I contacted him?
I don't know. I'm gonna try again, and then we'll see. Down there, and Kathy Ireland. Do you know who she is?
I do.
I know the name, but I don't know
I
who she
do.
She was a supermodel in the
Yes.
like 80s and 90s and whatever, somewhere in there.
Oh, and
So she's there, and she comes to dinner, and she helps kids down there in this fishing village because they have a lot of
She's
issues.
hot.
She's hot.
I got that from Supermodel, but
my age hot.
Yeah,
Closer to my age.
and she's she's really responsible, and she's really wealthy, and so she's trying to help get things like first supplies and things like that there to help them, because the kids basically don't have anything to do. They get their little yellow boat. They only go to about 8th grade, and they only go half days. That's their education system. So you can do a lot better than that. You better supplement that.
Right.
So she does it with after school stuff, but it's mostly singing and swimming and keeping the kids out of trouble, and it's not educational.
Yeah, but keeping them out of trouble really helps.
It really does. Alright. See if I'm gonna grab some more water. He was just showing up the real
Yeah, I know.
I just started wanting to bring the camera down or something.
Joe Varnell, Hammer Fist logo.
What?
Every time the logo breaks, you just run over.
Yeah.
Hey, I do that a couple times it's the most fun thing to do. I would
Harry, watch. Joe's gonna go Hammer Fist.
No, like, I'm sure you saw that a couple times where while you were busy this was while you were busy working through LabVIEW issues with that one.
Yeah.
You were there for like an hour off on
Yeah.
the side of the scoring table.
Sorry.
I was looking over. I'd see right before a match starts, the logo will be 2 inches up. Just walk over. Ding.
Actually, it's kind of fun, and
It
if you're
is fun.
frustrated, it helps.
Good stuff.
Until you hit it, and then it turns out they're just slightly misaligned, and it doesn't move at all.
I think I've done that.
I'm sure you've done that. I think I remember hearing about that.
So, do you guys do? You do VEX still, or do you do it with other schools? Or do you do VEX IQ?
had been doing VEX as a competition team. This current fall, we will not have competition teams. We will only be running events.
Do you mentor best? And there's just photos of your own best.
No,
No
we
longer?
did. Before I got here, we were a best team. In my first fall here, we were 2 different best teams. We stopped best that year for a variety of reasons. One of the creativity challenge is cool, but doesn't translate to FRC again. If they don't know what a planetary gearbox is by the time we're doing it, nothing really helps. But then also that year we had the single worst experience I've ever had at a robotics event, where they had Wi-Fi killing routers. I told them what the problem is. They said, oh well, we're not going to try to fix it. And I said, I'm done. Kids have fun. I'm literally not participating in this event any longer. I've never had to do that before, and I was like, I'm done with the best. This is ridiculous.
We had an event where they had brand new refs or whatever, and they didn't know rules, even though I guess they'd gone over some of them, but not all of them, and so there were a lot of arguments between refs and teams and other refs.
Yeah, like we support events. We'll go. We didn't volunteer best this year because the timing didn't work. We volunteered best the year before, and we'll volunteer best anytime that the weekend's open, which is pretty rare. That's our biggest problem in the fall right now. Right now I think I have 2 Saturdays between the second weekend in September and the second weekend of December that are not taken. Like literally every Saturday's booked.
We do the 4 first events, and we also do WRO, which isn't in the US right now. So it's like the rest of the world.
Okay.
World Robotics Olympiad. So it is like an FLL, even up into the high school level. In fact, the kids have to show up with the robot cannot be assembled.
Oh,
for most
so they
of
have
their
to go
levels. They
Oh,
go
it's
from a
that
box of
style.
parts
Gotcha.
there, and they have a 3-hour quarantine period where the mentors cannot be with the kids. The kids have to build the robot. I don't know if they have to program it. I've never actually been to one because they really do it like the Olympics. It's in like Jakarta, or I mean, it's not in the U.S. So it's in Malaysia. It's in this year. It's in Sochi, and so they kind of go to like the Olympic villages and that kind of thing and
That's
do it.
cool.
And
That's interesting. But it takes. I mean, the same problem with Best has that same issue of it's supposed to be student done.
Yeah.
Like the mentors aren't supposed to do as much, and that's fine. Except the point of the FRC model is you're working alongside somebody.
Oh, they
and
work
they're
alongside
teaching.
them, but they have to show that skill when they get there. It's really more than that. The kids have to put the railroad together 50 times, but they have to do it again.
Oh,
Okay,
I would hate that event.
It's a little, you know,
I
like.
would hate that event so much.
Well,
And the more complicated the robot, the harder it is.
Yeah,
So it kind of
that's
has
so bad. It's like Thursday at FRC when you're playing back the robot.
Yeah. So there's that, and then what they did was they opened up a collegiate edition, and it may start using the MyRio. That's one of the reasons we're getting more involved.
And collegiate, I hope
And they use-
that is more complicated.
Yeah. So it's going to be. They did it last year. I knew the guy. It was a former Lego guy. I knew him that designed the game last year, and it's Matrix and Tetrix.
Okay. Yeah.
So it's really
Like
on that
FTC,
level,
yeah.
but it's all autonomous. It's that you were talking about. It's
I mean-
100% autonomous. They don't even go out and touch the robot. It's
See, I like that where they set it up.
Here's the thing, Joe. Here's why
Problem.
the whole autonomous versus not autonomous thing. Here's my argument. Almost everything you build in reality and for real products are used by humans. So to keep teaching kids to program something that's going to be used and driven by a human is very valuable. There are very few things that are built and used that are fully autonomous. Extremely
SMSS,
small number.
Mule.
Yeah, but there's one other reason.
It's
you're
that
gonna
hybrid
go
I
with-
want to promote.
Right, exactly. You want to be able to
Well, see, that-
automate. So that's what I'm saying. Like our drive code, when you're like, it's not an RC
That's
car.
even more common.
Our
Well,
RC
see-
isn't an RC car. Like they have to learn the drive code. They have to interface with the driver. We're tuning stuff to make it better for
See,
the driver.
that's what I see is almost everybody it's a big RC car, and what one.
Well, some of the teams make a really smart RC car.
Right, and that's
and
the
they-
thing. It needs to be a smart
That's
RC
what.
car.
yeah.
That's what I keep pushing, and some teams just push back so hard. Some very experienced teams
I
just
know.
push back so hard.
Yeah.
No, my son can drive. He doesn't need all that stuff.
But it doesn't have to necessarily. But there is a line, right, between
Well-
what is useful to have a program do and what is useful to have a human do, and then how you can make an interface to where you help the human. It doesn't even have to be a complicated. It doesn't have to be smart. But if you button layout is one of the things that we go over every year. Is how should this be for the driver? What is the human interface involved in that? That's probably from my training because I was a human interface guy. But
And what the Lego kids do instead is they have to go through the task that the kids at the table have to do
Right.
because they have to remove mechanisms
Oh, I
and
know.
put other mechanisms on
Yeah.
and like reconnect things, and so they have a human element.
Yeah,
to
they
it.
do.
oh yes,
They
I know.
totally-
I just
It's just different,
yeah.
you know. And I also really like the fact that they make him do reports and stuff, which would never go over well in FRC.
No.
Oh no.
And I mean, I
but
like
it's-
and dislike the requirement because it hurts starting teams because it's so much. That one of the reasons I like the VexIQ system is that you don't have to do that side of it. It's there, the research is there, the kids are learning things. It's a little bit less gimmicky in my mind because a lot of the FLL stuff is like, we're gonna make a thing where you don't have to touch all the donuts, and I'm like, that's silly. What did you actually learn from doing that one? But there's this math stuff, like they had to do like Fibonacci sequence last year and some other stuff. So it's a little bit less gimmicky in that realm where it's not a skit.
Well, it's not always a skid. I mean, like you said that last year there were 54 teams that got provisional patents from FLL.
Oh, yeah. No,
And so it's like these kids are coming
54 out of, what is it, 15,000 teams?
No, 5,400 submitted their ideas.
But now, how many?
No, 540.
But how many FLL teams are there?
Not everybody submitted, right?
Right. There's something like 15,000 FLL teams.
That's true.
Right? So you got
a lot of them don't.
Right. So I mean, you're
Some
going to
do.
get some great teams no matter what. It's a matter of how do you make everybody up to a certain level of what a single individual kid in an FLL like.
Yeah, but I mean, with FRC, you don't have that same level. I mean, there's the top tier teams.
One of the really cool things
So-
about it is it gets the kids and the teachers have an ability to incorporate that into the classwork. The kids are doing reports; they're learning tools.
Well,
so it's not
also,
just the robot.
It's a lot about the research, and
Yeah.
that was kind of Dean's whole thing. It's not all about the robot. They want him to do research so they can start learning that aspect of it.
The year I judged, it was actually it's been a while. It was when we did the NXT, but it was about accessibility. And so the kids actually would petition for curb cuts and stuff like that in the communities, and they wrote papers so that the VA opened up. They gave them a list of names they could go talk to people who had lost legs or limbs or whatever, and had to live with that. And so that's the kind of exposure the kids got. Yes, it's about donuts. I agree, but man, that was awesome.
Senior
No, and
Solutions
some of them do really great things.
Yeah.
But not everybody, and there's a ton of work in getting it involved, and there are great things, but it's hard.
Senior Solutions, one team had like one of those help buttons, but really all it did was it measured falls, and so if somebody fell, it would automatically contact. And now I see on commercials on TV for that life alert or whatever, it detects falls. Okay, this is part of that.
I mean, just the fact that some teams do it and other teams get exposed to it, I thought it was awesome.
Yeah.
And I knew some of the mentors who, anyway, Danny continues to do FLO.
Oh, absolutely. I'm not saying that both programs should exist. Right. Both programs should exist. It would be like if I was an elementary kid and I could do both, I would happily do both.
Yeah.
But there is something to be said for the sport of it and being able to expand it as a sport and getting that knowledge in there in that competition side.
Yeah, and in fact, I'm glad they are different. The weird thing is that at this point, Ducks and FTC are still so similar. Yeah. It's actually one of the things I've been trying to push is for FTC to differentiate itself. And they tried a little bit with the manufacturing bit, which I was actually trying to get Vex to pull. I was really close to getting a second Vex division.
They're moving more toward the manufacturing, but what else could they do to differentiate themselves?
So the push I had that
different size
to the point where I don't know how much they didn't tell me not to talk about it, but so I can talk about it. We were pushing them to get rid of Vex U because the turnout hasn't been nearly enough, or Vex like university.
Yeah.
There aren't nearly many U.S. schools. There's quite a bit in Mexico, but not enough for it to really stick around. Like it's okay, but it's not great. Like you still just randomly sign up for the World Championship. Like you don't have to compete to get in or anything. And the goal was to basically make it Vex Unlimited, or Vex Open is what I called it, but they wanted to actually change Vex U. And you could use anything. You're still limited on controller and motors, safety stuff like normal, but you could use any 7.2 volt battery. You could use any metal. You could use sheet metal. You could use any plastic machining, whatever you want to do. Playing the same Vex game, there was some discussion on whether you built one robot or you got rid of alliances. So you either built two robots to play or you built only one robot and it was one-on-one. So there was some discussion about it, but basically it would be a much better. My goal was to have a much better technical training ground for FRC students where we have a program that does the grace professionalism, competition, cooperation, all of that stuff. I need something in the fall that says, here's how we can learn to 3D print gears, and then we're going to go and compete with it.
I'm thinking over time, FTC may move that direction.
Yes, but until their kit of parts is better, because I'm never using their motors. And I'm not programming on the NXT, sadly. So,
well, see, you don't have to use the EV3 code. Although I like the
Dominoes, yes.
I like the new setup. You can see what everything. But a lot of people use Robot C.
Oh yeah, it's super popular.
Vex can sometimes use that Easy C crap, and it's like,
Easy C.
Aaron, can you come help carry pizza?
I can't do.
That's why I ended up coming to this thing.
I'll listen to. See, I guess maybe I've been programming too long, but to me, all these different languages are just different tools. And so if you use an IDE, then it's really just a different IDE. It's just learning where the right menu item is.
Some of them are better or worse for each. You know what? I'm trying to figure out what type. Let's just open them up. Yeah. Looks like Hawaiian.
Hawaiian. Cheese.
Oh, HN. It's Hawaiian. S-I-R-R.
Where does it say the letters?
Oh yeah, there's a bunch of random pizza types. There's
Okay,
three. There's at least 3 cheese, and there's
PS.
for some reason snacks back there yet toilet cutlery and
Oh,
stuff.
pepperoni and sausage. You got pepperoni and sausage. PK,
I can give you
pepperoni
the
and
receipt.
No, I mean, we're looking at it's fun. It's full of fun. Here's cheese. Where's
that looks like pepperoni and bacon.
There's a pepperoni bacon. There's also a chicken bacon. I like
weird.
bacon pizza.
See, I've never liked chicken on pizza. Oh, this looks good.
There's like
I
a
have no
steak
idea what
beef.
it is.
I think it's steak beef. So I made one that didn't have pork.
BTN. Chicken.
there's another cheese.
Yeah,
Yeah,
yeah, those are 3
Should be
cheeses.
3 cheeses.
Oh.
There should be one that has no meat.
Chicken.
That's like vegetables.
Yeah, that's right there.
Here's. So do we just?
I'm just making files.
Yeah, most of these are like.
We'll open them up when there's 15 people here.
And there's plates now.
Oh, we can
So
start.
now time to bring down the hammer.
You can get your food first.
Oh yeah, it was hilarious that robot reboot these things.
The nice things about, so one of the things I will give Vex credit for is when they make a mistake, they attempt to fix it in whatever way they possibly can.
Good.
So we had these 6-inch rollers, right? We had them on our drivetrain. So these are, well, there's a 4-inch wheel, but these are the rollers that go on their 6-inch wheel.
Yeah.
We broke one off after about 6 to 7 hours of driving, just like we were just running it upstairs, practicing, testing, prototyping, all that stuff in the middle of the week.
Go ahead.
We broke one and we were like, oh, this is a mess, this is ridiculous. I sent emails, blah, blah. Eventually got Copioli on the phone, he was like, yeah, so here's what happened. We didn't have the 4-inch rollers that we thought we were gonna have, so we shipped them all with 6, we thought it would work. We were wrong. We're gonna try to make this right. They shipped our team, we ordered 10 of these wheels by that point, because we thought we were running it, so we were ordering backups in case they sold out and everything.
Yeah.
So there's 6 roller per wheel. Yeah, we had 60 of those or whatever. And then they gave us 60 more of these rollers. Then they gave us 60 of the 4-inch rollers. Somehow we ended up about 200 of these little roller modules because they broke and they were mad that they broke, so they were trying to make me happy. And they just kept sending me free stuff. And I will never use them again. I'm still mad, but we were able to load them out and other people were using them and fix them.
Yeah, I think Greg's doing a good job.
If FTC comes on and makes control systems that I won't throw my head against, I'll be more happy. And possibly FTC. Also the field is my problem. I don't like that you have to construct the field. I hate that. Because they're not the same menu to menu. That's a big problem.
What?
This is not consistent enough?
Yeah. Anytime you have to construct the field, it's not consistent. No, not that. You have to construct a box, or you have to cut open a ball and put that in. And anytime you have to manually do something, somebody's not going to take the care to do it right. We're going to design something that pushes performance where it needs to be right, and we're going to fail to the field. They don't spec it well enough. Something along those lines. That's the problem with best. That's one of the reasons I got out of best. It's never even square.
And actually, I remember there was one camp we went to for Vex, 704, and they didn't even check any software stuff. And about half the teams didn't use templates, including 704. Our programmer wasn't there, and so I had to sit over there and cut and paste out of one. Oh yeah.
They didn't run it. They were
Wait.
running it on time or something.
No, if you didn't, they had like a autonomous template, and 704 didn't see the thing to use, where to get it from or where to use it, and so they didn't use it. And then all of a sudden, it just got there and screwed up. And they said, "Oh well, it says it in the forums." Well, there were 84 pages of
What year
forums.
are you at?
That was like 2010.
Okay, it's gotten much easier. And I mean, basically, you have the field switch and you test it to make sure, just like you test in practice mode on an FRC robot, you make sure you go not and make sure you go into the board.
Okay, so they fix that.
And it's open on programming languages. Whatever you can get to run on it and follow the rules is entirely legal. So there's none of the safety stuff like FRC. So now there's 2 different open source versions. One of them is basically you have full access to the ARM processor. You can do whatever you want.
Yeah.
That one, Convex is scary. Provex, or Pros, sorry, Cons and Pros are what they're called, which is hilarious. Pros is written by Purdue. Cons is written because it was an opposite of Pros. Yeah, it's all that kind of stuff. But Pros is pretty useful. It's all in Eclipse. It runs really easily. One of my kids can basically never program microcontroller before. Learn to do it pretty fast. And when they get key stuff that translates much easier down and stuff.
See, whenever I go talk to rookie teams, I always say, go to the computer class and find a hacker kit. They're your best resource.
The other reason I don't like paying for licenses, so I don't like seeing all those. I refuse to pay.
Actually, I went to Robot C and I got, before they went to the way they do the licenses, now I got a license that was
Meridian?
Well, it was for forever. So I don't have to renew it every year.
Yeah.
And I'm grandfathered in. So they say I keep getting all the new updates. I just copy. So.
You see that I have a simulator and some more stuff in the simulator.
Yeah. Well, I went to the partnering conference at the Hello. And I saw, from your cohorts, what's her name? Young lady. She transferred to be her cohort.
I didn't know everybody's name in the.
Okay, well, apparently she was transferring at that time, and I have a card, but she needs to stop saying I can't be there for that. See her, tell him to stop saying. I told her, I said, as a suggestion, like they got distracted.
I know it was somebody else.
I say that.
So that's.
That's all right. I mean, sounds good. It's just whenever you're up there presenting, certain presentation things just crap out.
Yeah. So that's part of the reason I
Okay.
I'll send you the faxes.
Yeah. Yeah, talk to you, he knows all that stuff. She didn't seem as. She was, said she was in one group and she was kind of like a counterpart or whatever.
She's been mentoring a new FRC team. She's doing really good. I put all the data on the
Okay, maybe we're not talking about the same. It's not very Kurt wasn't very curly. It was
shortish.
No.
So nobody else.
That's all right. It's not like it. I didn't like it.
Well, I could swear it's hard because he keeps bringing Verizon.
Maybe it is her. Maybe I just don't remember what she looked like.
We have some of these.
Anyway, that she was talking about. Picking up people.
They were told there's pizza, right?
Well, you can smell it, just, there's no doubt it's here.
See, for most people, that would be a drawing itself, just the smell of pizza.
Smell it.
Busy drooling over the robot. It's annoying just trying to find a water bottle.
Today. So last night, last night I got a call. Well, last night I got a call from Lucian inviting us to go practice at Santa Carter. Yeah.
Oh, awesome. The guy from the Dallas. personal robotics group, right? Robot C, right?
Big Swan?
Yeah, that's his name. I never.
Yeah, he was the
remember.
original author. Then he paired with CMU to help with distribution and content and stuff like that. And they helped a little bit.
testing and all. Yeah, he says he writes basic stuff.
Because he originally wrote it for, he wrote and rewrote portions of firmware for Chris Rogers for RoboLab. And that's actually where a lot of his, he just wanted to put the Robot C stuff on top of that, so he started building up from the firmware. And that's sort of the kernel part of it was all written by him. And Tim Frietz is the primary student, or he may even be a teacher now at CMU, who manages to do the rest. The business guy is Robin Chu.
See, I'm trying to remember the CMU guy who was at the partners conference.
So Robin is older, Tim is graduate student age.
This was a graduate student age kind of guy.
This Tim.
They use 4
They do a good job.
It seems like after talking to them,
But it is a business.
all there. Yeah.
To them, it is a business. That's just how they make. I mean, Robin gets grant money. He's in all kinds of things, but they treat Robot C as a business. Right?
Well, he did say that they want to be big enough. To, the Robot C kind of division or whatever really big enough.
Well, I mean, they
do a
get
lot of donating.
They get money from VEX. They get money from a few other things and FTC. They still charge FTC dues.
Right. They still charge everybody, which is one of the reasons why I don't like
It's a business.
FTC at the point, because I refuse to. We have such a mobile area, right? Like every kid has their own laptop. We don't have a computer. We don't have a classroom license. None of that stuff. Like it would get the expense is not worth it for the number of people who want to do it. For the features we're not going to use for the most part anyway. Before this season, the previous season, to get through our VEX season of actually competing, we just cycled people's computers with a 30-day trial. We were like, how many laptops do we have? All right, we can get through 3 months if we go through this many people's laptops as a programmer. All right, you're the programmer in September. You're the programmer in October.
I've seen people do that before.
It worked well. The open source stuff though was really, really clean this year. Had very little problems.
Hey, here's a guy who used open source on NXT. NRC or something like that, or
Yeah, the not Robot C.
Yeah.
yeah. Oh, okay, that's what NRC.
They hate each other. Different guy.
Sure.
Dick Swan. So basically, he set out to do the same thing but for free. John Hansen. So they're both nice guys. They just see things differently. So.
That's what makes the world go round.
He previously worked on the one that was for the yellow brick.
NQC
was NQC.
NQC was fun. That's how I got my
Oh,
start.
okay, I remember
So
that
that's
one
where John
too.
Hansen got started.
That was probably
That
was the first bit of C code I ever did. That was in like middle school. Doing NQC stuff.
I still have a yellow bricks.
Back whenever I was in school, all we had was these 2 teletypes.
Oh, we had
for the
nothing to do.
central
That was not in
computer,
school
like-
at all. That was. I had a Mindstorms 2.0 kit. That was all at home. Me
Oh,
hacking
okay, I had
away
all
at
this
C.
stuff,
That had
okay.
nothing to do with school. Yeah, school had no programming at all.
I took
I dug
computer
my,
math.
my
with
yellow
programming.
brick and
The
picked out a
only
couple.
I took AP Computer Science my senior year of high school after I'd
I
already
mentioned
done.
calculator contest a minute ago, and I was like, yeah, that's good with these.
See,
It's like they had just started the calculator when I came through. I did not do slide rule.
yeah. Yeah, when
Our calculators had LEDs, not LCDs, so.
In the evening.
well, I just remember the 4-function calculator that was, this big. As big as a TI-83.
Yeah, I don't remember that.
Yeah, most people don't.
I got my computer-wise. I got my start on an 8088 machine. That was fun.
Even in college, we used cards.
Joe, you're old.
And by my start, I mean when I was like 5. But
One of my best programs I wrote was like 2 boxes of cards.
And then
and so to program to run it through the thing, you'd have to take some out. You'd take some. You'd have to kind of cycle it through because the card reader couldn't hold 2 boxes worth of cards.
And you felt that pain when someone dropped their box of cards.
Yes, and after I did that, I didn't drop the 2 boxes, but smaller decks I dropped, and after that I learned about sequencing.
I'll actually.
You'd also just put the big marker slash.
Oh,
on
the
edge.
marker slash.
Which is good for rough sorting.
I didn't do that. And, well, because you could.
I didn't do it either.
You could really
No
sort
love it.
it. You could sort it if you had the numbers on the end. Then we got Wilbur, which was really cards on a CRT.
We had Wilbur when I was in college.
There you go.
Ops Wilbur.
Did you just mention Wilbur operating system?
Was it it wasn't an operating
no,
system.
Stanford
Yeah.
used Wilbur.
You guys
I
need to
used Wilbur.
take your walkers over to the.
No, that had word processing in the 70s.
Alan, look what you've done.
I don't know about work.
All right.
We used it.
Quick, get them talking about things in the present day.
I'm gonna get people's attention. There's just a few people outside. Mostly the students.
All right, we're gonna do a little bit of presenting during lunch. Greg's gonna finish up what he was talking about. So if everybody can have a seat, please.
Alright, so I was able to get my laptop resolution stuff fixed. So as Alan said, I'm just going to show a little bit more. And we'll continue with QA as long as we want to talk about software stuff. And I think we'll show some of the smart dashboard stuff because I don't have it on my laptop. So I mentioned earlier open up examples, the help find examples. This is the sort of thing that is in there. So on the left, you have your parameters that you can enter in to control a very, a different robot, different wiring for the robot, so you can make the software match the robot. And on the right, it actually shows you in a schematic what that wiring needs to be, what the expectation is. So if you're going to do pneumatics, if you're going to do an encoder and a motor and potentially some control or something else like that, it shows you the elements that you need to wire up because it's not all just software. That's actually one of the really cool things about FRC is it's not just some analytical mathematical thing. It's a combination of real world and computational thing. But you have to know how to do this, and often the students are good at this but not that, or the other direction. So this helps, I think, quite a lot. And then you flip to the block diagram, and so it starts to introduce them to the functions. We were talking a second ago about what people know from AP courses or whatever. This is also the language that's been used in FLL for the whole time. So if people they may have LabVIEW knowledge and just not know it because it's not called that. This is the Lego software, this is the FLL software. It is the professional version, so it's not super simple. But anyway, this is what block diagrams look like with comments and things like that. And again, they can use this to try to figure out how it differs from their code. If this works and their code doesn't, or if this doesn't work, it's probably a hardware problem, or an electrical problem. So. We also mentioned a minute ago about drilling down into them to see what is actually in these functions. So I'll do that real quick, and then I'll switch over. Now, ignore these broken arrows up here. One of the things about LabVIEW is it tells you when things are broken, the little run arrows. This is broken because this is actually in the beta code, and it broke just before I came. So just some of the examples are broken for the C-Rio, not all of them. Anyway, if you start drilling down into Java functions, drilling down into C++ functions, drilling down into LabVIEW functions, you'll start to see the implementation. So this is where you actually start to see some of these parameters get used. And what type of encoder are you talking about, right? We'll link all different functions. So, for example, if we want to, eventually in LabVIEW, you'll wind up at what I call just purple nodes. It's not as purple to you as it is on my monitor, but basically this is a node at the very bottom of the functions that actually reads a register on the FPGA. So you let the kids go all the way down to the point where they're seeing the code read a register, and they can watch this work. And in fact, most of these integers aren't even full integers. They're like special, like 9-bit or 12-bit integers, the kind of stuff you get exposed to if you were programming the FPGA. So, it gets pretty geeky if you want to. You can go down to this level in Java, C++, or LabVIEW. And all it really does is, most of these are simple little functions doing math. This one gets the FPGA reference, so this is the session handle to the FPGA images running on the controller. And it goes into this purple node and it comes back out with some data. It returns it back up with some value and direction counts. And then up above, it starts doing math to try to figure out how far you've gone or how fast you're going. That's what encoders do. Down below this is where it actually is looking at the rising and falling edges of your signal and increasing or decreasing counters. So that's where you can have that conversation with them if you choose to. So anyway, there's a lot in the examples. I think it's a great way. Start out here, see if they want to see more, see if they're already scared, whatever, you know. You give them little things, go make this work, and you come back and help them enter this in and run and see if they understand the way the numbers change. See if they understand scaling and averaging and all that kind of stuff. It's all pretty well exposed, I think. Other examples that aren't FRC related, we actually ship our full academic robotics library, including the simulator. WPI is working on a simulator with Gazebo, so it's not out yet. It may go in beta soon, but the robotics environment actually gives you pretty cool analytical kind of things. This is an example also that shows your wheel velocity for different wheels in an Ackerman steered robot. I'm not going to say an Ackerman steered robot is a great thing for FRC. They're everywhere all around you. So
Ackerman steering,
yeah,
is car steering.
Yeah, exactly. So talking about it with kids, talking about car steering and why you hear squealing on one tire if you don't have the differential that slips. Well, this shows it because on your back axle you've got different lengths of these arrows can't turn. Therefore, they have to go different speeds, and therefore your tire has to slip if you don't have a slip here. So you can have that conversation with them just with the software on the whiteboard, however you want to do it. You can build it in Lego. But there's some really good stuff in the stuff that's given out for FRC. There's even a crazy one. I think I opened it. One second. Yeah, configurable steering. So this is you're mentioning the 4-wheel. So this is your crazy robot, your Omni robot with as many wheels as you want. So if you want to have 9, 7, 4, whatever, and so you can go in and it just. And the math's not really that complicated, but it shows them what happens if you want your robot to pirouette while it does this, while it does that. And if it happens to have 6 wheels, that's the math that you have to do. Those are the inputs you have to give in order for it to go like that across the floor. So all these sorts of things are in there. They are not even called out in the FRC tutorials because really they're not that relevant. There's AI things in there for path planning. There's vision stuff. There's just tons of stuff that's given out. We try not to distract everybody with it, but if you find a kid who that's where you want to send them, it's the same thing. If you want to download OpenCV and turn them loose or MATLAB or whatever, there's lots of software licenses you can get for specific situations. So back to FRC specific stuff. I showed you a couple examples, and now what I'll do is this is the project in FRC. I'll use this to talk just a little bit about the structure of the control system. This is done very differently between the different languages. I said a second ago, or an hour ago, whatever, that we tried to make them very similar. That was true at the library levels, right? And then what we actually tried to do intentionally was do the top level framework differently. This LabVIEW happens to do parallelism natively, right? So you can have 100 things in LabVIEW, thousands of things in LabVIEW running in parallel. It's a data flow language, that's what it does well. That's why it's used in the industry. Java does the commands and the event stuff well. So it takes a different approach to how you model your robot and how you write your code. And I think there's an iterative C++ and a command C++. So basically expose kids to different ways of thinking about your robot. So the LabVIEW one actually has these sorts of loops that are waiting for input and then executing your teleop. This instruction over here tells you pretty much not to change all this stuff. We're just showing you the work. And instead what they do is they drill down into teleop, and this is where they get their joysticks and update their motors. So if they want to do some math in here between getting their joystick, axis 1 and axis 2, and updating their motors, this is where they would do it. I have a turbo button, or I have a turtle button, or I have a whatever, or I want to square my inputs before I send them to my motors. So this is where they can modify that code. There's other things in here that's pulling back like those little I/O things if they want to have buttons and switches. There's the amount of time that has elapsed in the match, and these are the smart dashboard calls. So this is actually something that is going to, if I bring up the help window, what these functions do is these actually write data back out to Smart Dashboard. And Smart Dashboard is this communication protocol that works across Java and C++ and LabVIEW that will share data back to your dashboard, so the drivers can actually see this, so they actually can see what's being sent out to their motors and what's being sent out by their joysticks. So in case there's any other parameters, any other pots, any other LEDs, things like that they want to send out, or they can read things just by flipping this around. They can read it and they can have it affect their driving. If they want to have some sort of ratio or speed control or something like that. So that's the basics of programming the robot. The autonomous portions, well, that's just another VI, and this is an example of the autonomous where, and this was where it really does start to look a lot like Lego, where you get your motors, you set them up for a little while, you wait, you set them up a different way, you wait, you set them up a different way, and it looks a lot like Lego sequences in Mindstorms. Another way of doing that is shown down below. These are both disabled by default because we don't want people running auto code that wasn't written for their robot, because forwards, backwards, or sideways, or we don't know what motors are what. So until they fix the code, it's disabled, right? But this is a different way of doing it with a loop, where you actually just go enter in data on the front panel and you make little input data. So this sort of starts to teach them how you can either do it in code or you can do it in data. So it just gives them a tease, is all it really does. It gives them some structure. And then the rest of the autonomous is up to them. So, and the tutorials will often talk a little bit more about how to use these things. So that's the basics of the FRC framework for LabVIEW. Like I said, you'll see some very different things in Java, and you'll see a lot of things that are similar, and ditto for C++. Let me pull up the library in general and talk just a little bit about the new stuff. The LabVIEW palettes expose the functionality for WPI Lib. The primary additions this year, there's going to be some new sensors. These really aren't, if you've done this before, this may kind of take you by surprise. Why do you need a function to read a switch? It's just a digital thing. Why do I even need this wrapper for this? Or a pot, you've been reading it with the analog all this time. One of the reasons we're adding these in is so that the robot can be better simulated. Because if you're using the basic analog read or the digital read for a switch, there's no way for the physics engine to know where that is on your robot. Right? There's no physical entity that actually closes that switch. It's magic. So what we're actually doing now is we're actually making it to where inside here, you can actually have a name for that switch, and then you can actually put that switch on your robot in the simulator so that your simulator will know that when something pushes on this, that a value back here in your code gets modified. And that hasn't been possible up to now. It worked for motors and pots and other things like that, not pots, encoders and things like that. But we realized that we were sort of missing a few high-level wrappers for simulators to work better, so they're being added now. You don't have to use them. I think a lot of teams will sort of make fun of us for adding worthless functions because they know a shortcut and they'll do it the other way, but that's why we did it. The other things you'll find in here are the same, gyros and encoders and things like that. These have been improved in the different languages to support. Over the last 5 or 6 years, there's been I2C versions come in and different types of gyros and things like that added in. So I think you'll find these a little easier to use than they have been in years past. But it's the same functions, they just improved. On actuators, I don't think anything has changed, except the compressor will now, by default, assume it's going through the PCM. This will be a CAN wrapper, so this will send a message to the PCM to talk to the compressor. The PCM is that pneumatics control module that Across the Road is doing. So traditionally, the compressor was something that was done with the C-RIO. It was reading a pressure switch and it was controlling the relay to turn on and off your compressor. So it doesn't have to do that anymore. So if you are doing it that way on a robot, we'll make an example. But we assume most people are going to use the PCM if they're doing pneumatics. Okay,
so will the
that's a little
pressure
change.
switch
Yes.
connect to the PCM?
The compressor switch will go straight to the PCM, and the power for your compressor, the power inputs to your compressor will go straight from the PCM. And it'll do closed loop control there. Does that make sense? And the CAN will tell it whether the compressor should be enabled or disabled. And it will also tell it whether the compressor, you'll be able to read whether the compressor is currently on or off at pressure or not.
So if we want to run 24-volt solenoids, and there's a switch on the PCM, so we feed the board with 12 or 24, and then it sends 12 to the compressor, even though we're running solenoids on 24.
It does all that.
Great.
Yeah, I think it does simplify things, but it is different.
Wait, does the, I think it's, the PCM always,
always
takes
takes
in 12. The PCM always takes 12, and
Yeah,
it'll
it was-
switch between 24 or 12 for the solenoids. It switches 24 in the PCM.
Right.
Because there's no longer, you can have the optional voltage thing for 24, but I don't think it's there ever.
Right. Yeah, I don't think you'll have 24 volts on your robot anymore, except on the pneumatics leaf piece. Okay, so there will, and this is incomplete, but there will be a power API, some power features added, and this is where you'll be able to pull back your circuit currents and voltage for your power distribution board. You'll also be able to read the rails for your different, there's a 3, 3, a 5, and a 12 volt rail within the RoboRio, and you'll be able to read those as well. Again, I don't know what you're going to do with them exactly, but maybe some diagnostics. I can see people doing quite a lot with the analog stuff. The current reading, trying to figure out if their motor is shorting out or doing crazy things. If they're trying to diagnose something that they think they see in the field in a certain condition. So anyway, this is incomplete, but there will be a new power API. The joystick stuff is going to change a little bit. It's actually somewhat simplified, but I can show you in a minute. But it basically will support Xbox stuff, including Rumble, and the POV stuff is better. So kids who use joysticks won't notice the difference, and the kids who use the game controllers will like it a lot better. Camera stuff isn't changing that much, but it will now support USB and Ethernet cameras pretty seamlessly. So in the open, the camera address was already a string. Traditionally, that's a network address of some sort, an IP address. Well, now it can also be a USB name. And if it's a USB name, then it'll expect a USB camera, and it goes through a completely different code. But the user's program is sort of isolated from that. So in fact, we hope that you can switch cameras pretty easily without having to rewrite all your code. Because that's the way our examples are, so we don't want to rewrite all of our code. Communications, the typical things are still there, and the CAN library, I don't know how many people had experiences with CAN in the past. CAN is it stands for
Controller
AN
area.
is Automotive Network.
Controller area network.
Area network.
It's on the help, by the way.
Sorry, there you go. Well, it's an automotive network. That's not what the acronym stands for. Sorry. And so, in fact, they're all over your car. This is how your side view mirrors, move, and all these other sorts of things. And within the engine ECU, they're basically sending messages to devices within your car. So we're doing that on the robots, and but they've had some issues in the past with cables, and mostly it's robustness issues. So, but it's really good to expose the kids. CAN is a very good network. It's used throughout industry, so it can be done well, and we believe it will be this time around. So anyway, the protocol is changing also, though, to simplify it a little bit, because a lot of what would happen is that you would send a message to a device, and you would wait for the response from the device, and meanwhile, can you do another thing on the bus and talk to another device? And what happens on these robots is it's really kind of crazy, but you really want everything happening all at once, for the most part. These control loops can't wait on each other, and the CAN stuff was hard to write correctly that way if you gave that to the users. So we're actually pulling that stuff down a layer, and we'll be responsible for that within the CAN driver. It's not really the driver, but these utility libraries. And so it should be a lot easier to use correctly, both hardware and software. So CAN are some very big changes. I don't know that I can really describe it that well. In fact, it's not even finished. But there's still some very low-level stuff. This is called utilities. And this is one where I don't even think all of the libraries have this, but LabVIEW has interrupts in DMA and stuff like that. And then one of the things that, again, is when we show the smart dashboard, or the smart dashboard in a minute, these are those icons I was showing you a minute ago to share data between your dashboard and your robot. So these are really important if you want to know what's going on your robot. Because again, it doesn't have a display, it doesn't have a monitor. You guys put a little like readout on for your voltage. Pressure.
That's just voltage. That's just straight. That's just straight to
right.
battery.
Most teams don't even do that. You're lucky if you have an LED. I mean, it sounds right. That's about as good as you get most of the time, which is fine for some robots. But if you want, and I would encourage you to go ahead and have the kids prove that it's working right. Right? Just give them that little challenge. Let's not guess. Let's measure it. Right? That's one of the reasons NI is doing this, is try to get people to think in that way and encourage that. So when you measure something, you need to do something with it. You either write it to a file, you put it in a print statement, you send it back, or you put it in a value like this and you display it back on your dashboard. You may not ever use it again, but whenever you think it's broken or you want to make sure it's working, that's, you'll be glad you're publishing that data, and you go look at it, and then you can like talk about real data and not, guesses. So that's Smart Dashboard variables, and there's lots more documentation on all this. I'm just trying to go through pretty fast, hitting the highlights of what's new. So speaking of which, what's new in the driver station and the dashboard? There are a few things. So close down. This is the new dashboard, and let's see. I may not have actually launched the new driver station yet, so let me go launch that on my desktop. Sorry, I had to restart to do a bunch of other things. So the new driver station looks a bit different. It's not super different, but those tabs that were across the top are on the side now. So this is your driving tab, your operation tab. This is still your diagnostics. This is still where you go to look at your ping devices and your memory and other stuff like that. Oh, and your version numbers. One of the most common things, again, that Joe and I kind of deal with at events is you get there and people don't have the right software installed. And I mean, I don't blame them, to be honest, because it's confusing. There's so many things on that robot, it's crazy. But if you don't have the right software, first you may very well say you can't get on the field until you install the new software. So before you ever go to an event, and we're going to try to simplify this numbering scheme, but know what your version numbers are and maybe try to figure out if you have the right version of things. And this is how you find out. Right? Here, yes?
I guess I'm confused. Aren't you supposed to upload the last version?
You are supposed to upload the last version, but things change during the season. So this is where it's too much like the real world.
Oh.
There's a bug, there's a safety issue, something like that. There are updates. Some of them are mandatory and some of them are optional. So part of the problem is teams don't even know that is an issue. They don't even know what version they're running. So we're trying to make it easier and easier to know what it is you're running. We may go so far as to tell you you're out of date. We don't have that mechanism yet. But somehow you need to know whether you need to do software updates, because it's not so easy at an event.
No.
Because we don't have networks and things, and you end up like trying to take a phone and do a thing, and it takes a while.
Find the one person with the flash drive.
Your battery is going to run out then.
My battery? Oh yeah, I'm not worried about my laptop battery.
Not your laptop, but
the robot battery?
Yeah.
Yeah. So another little difference you'll notice. Yeah.
It'd be useful when you guys name the files, put a date on the file when it was effective. The C++ guys do that, so you can tell, oh, this one's newer than the last time I updated. Okay? NI, it just says, oh, this is the driver station update. Okay, which one? Was that the one that came out 3 days after kickoff, or is this a new one?
Oh, you're talking about the installer version? The installer name? Or the link?
If you, because the name of the file is just generic, driver station update.
Yeah, you're talking about the
Put
installer.
like
Okay.
a date.
Yeah.
So we know if it's an old file, a new file, whatever.
Okay, I understand. Yeah, and I agree with you actually. I don't do that, but I can give that feedback.
Please.
So one of the differences is
the version that you talk about is not the version that kids use, because you said, the competition rule may change during the season, and then they may need to update their software.
So there are multiple versions.
Yeah, so
there are versions of the driver station itself. There's a version of the software that the firmware effectively that's on the RoboRio, and there's the version of the library that they're using, and there will also be versions for the CAN devices.
If they
So
when they have
none of those are student written code versions.
Okay.
None of, all of that
This is-
are
So
software.
provided
and
in
all
the-
of that version numbering stuff too, knowing what version you're supposed to be on is in the inspection checklist. So before you go to the event, if you do the full inspection checklist, you should check that and know the version number. And it's on the inspection checklist of what's going to be counted for that event that weekend.
And it doesn't change that often, and we attempt not to change it, but something usually changes each year at some point. I mean, if it's a safety issue, it will get changed.
Yeah, and there's
we can't help
announcements,
it.
and when they change it, they update the inspection checklist and they send out an announcement saying the inspection checklist has been updated.
But better yet, it's probably good to have someone on your team that just checks the team updates every Tuesday. I think it's Tuesday they come out, right? And just have someone on your team who is the team update guy. And their job is to go to the webpage on every Tuesday or Monday or whatever day it is and see if there's software updates, rule updates, all those things.
It's Tuesday, Friday.
Right. Okay, so another difference between the CRIO and the RoboRio. So the CRIO ran VxWorks operating system. It's not a full protected operating system. So things can pollute. You know, they can affect each other, right? So if your code did something and something crashes, you don't really know what bad things it did before it crashed. It doesn't have a walled garden, right? So that's not true of Linux. So people have been complaining a lot about the time it takes to restart the CRIO and how often you have to do it and things like that, and that is, it's a valid complaint. One of the things to, I guess, make sure that we're not in these habits, and we realize there's a benefit we can go on here. You can still reboot your entire controller. That makes sense occasionally, but this is a Linux operating system. It is protected. Usually all you need to do is restart your program, right? And that does not take as long as rebooting your controller, just like your PC. If Word crashes, which my wife reminds me all the time how often Word crashes, she does not have to restart her whole PC. She just restarts Word. This is true of your students' code and anything we write as well. So habits about rebooting the controller and using the hard button and repowering the robot. There may still be reasons to do that, especially if you have other devices, but if it's just on the RoboRio, we really expect most of the time you'll just restart your code and it'll be about a 5-second restart.
If you e-stop with the spacebar, you can do that?
No.
Okay.
No, first is a real...
That's why I was making sure. That's the whole point of not using the spacebar, unless you're actually, it's a safety reason.
Right. But there's so many teams who you're like, hey, let's run your program again, and all they have to do is hit the run button, and instead they'll reach over and hit the Anderson, and they'll like, we're all standing there for a minute now. So, so yes, the spacebar. First is really picky about the safety things. They have to be. You should be as well. And we've had this discussion over and over and over again because nobody really likes safety systems. You know,
right?
Just seatbelts, whatever. I mean, we don't like them. So, but they want you. If you e-stop the robot, they want you to go visually check it and make sure that whatever happened isn't about to happen again before you just go, oh, let's do the dangerous thing again and again and again, right? So that's, I know it's not a good explanation, but I've tried arguing your point many times.
Well, no, I'm fine with it being there. Just when you're debugging stuff, don't hit the spacebar.
Don't hit the spacebar.
Are you saying then that when we reprogram the Rio, we don't, or RoboRio, we don't need to power cycle it for the new program to?
That is correct. Cool. Right. So all the cycle times will go way down.
You didn't need to. Oh, in Java, you never needed to do that.
You did actually for a while.
I mean, you could run and disable or enable.
If you deployed, I think. Anyway, all the cycle times now are simply a restart of your program. Let's see, other differences. These messages, these diagnostic messages are always up here on top now. But if you want, you can show the charts, or you can actually show both of them, which is really kind of cramped unless you have a bigger monitor, but this will take advantage of that now. So all that stuff I was showing you earlier is still there, and in fact, it can be up while you're driving. The setup is still very similar. One of the cool things we hope to go through is that instead of dealing with static IP addresses, you'll now be dealing with named devices, and it'll work like a printer or a camera or whatever, and you can find things on the network more easily. The setup, so if you do have a joystick plugged in, you know, and people want to test their joystick, that's not the driver station, that's the virtualized stuff, but here's your, you know, your testing of your driver station, your joystick. So I think people, like I said, yeah, that's been on your operating system before, but it's another thing. You want to make sure you're using the right joystick. Teams go up with 2 blue joysticks and they grab the wrong one and they're wondering why the robot's not driving right, and often make a mess while they try to fix it. So it's a good practice
Is
to
that
get
going to let
into.
us use more joysticks now too?
Well, one of the reasons it has more is also that things like the First Touch and the
Right.
stock robotics will be USB devices
Right.
like joysticks. So
That's what I was hoping. Because we do that right now, and we lose a joystick for it. So.
yeah.
Will it automatically, I mean, that one's named, will it automatically name them correctly?
So we don't have it in the protocol yet, but this information should go back to the robot as well, along with the capabilities, because they are different. I mean, this one has six axes.
Yeah.
Some have 3, some have whatever 5. And so that information, including these names, should actually get back to the robot. And so you can actually have the code on the robot adapt a little bit if you think that's something you want to do.
That could be cool. You could have a demo joystick.
And this isn't done yet, but this is some amount of diagnostic power. CAN stuff will also be pulled back and displayed here, so we can see if you're having an issue with some bus or something on the robot. So right now that's not working at all, and we don't have all the protocols finished, but that's what that will be for. So that's briefly. I mean, that's an update on what the driver station will have. One thing I guess I'll also point out is very few teams use is that there is a record and playback feature in both Smart Dashboard and in the LiveView dashboard. So in terms of logging what goes on your robot, this can't log everything. But what it does if you're running a match is you record, and it will record your video of anything that's coming back. It records all of your I/O things from the little Cypress board I had, and it records everything that goes over Smart Dashboard, which includes all of your joysticks. I'm not running on a robot right now, and I'm not going to try to simulate a robot in front of everybody, but basically it'll show your 2 joysticks by default, your 4 motors by default, your battery, other things that are on these other pages if you happen to customize, and all of that will get logged, and you can play back after the fact. So the kids basically have instant replay. Again, trying to make it to where the data is involved and not just guessing and arguments and whatever. So the more you put in the Smart Dashboard, the more valuable that becomes. But you can then, pull up old matches and run a match, right? And it has your video, and it's just an AVI file. So you can go play that independently if you want somewhere else. But you can play it in here, and it will actually animate your dashboard and show you what the driver was doing. Were the sticks all the way forward? Why didn't you have the sticks all the way forward? You can have those conversations with your kids. So, yes?
All these log file will be automatically saved.
Yeah,
when you are
it's done on your driver station computer.
Okay.
Yeah, and as you said, it's not just on matches. This is every time you connect to the robot.
Practice,
Some of these log files are made. This one is only when you ask for it, because if you have this laptop, it's not really going to be able to log all of that and do everything you're asking it to do. I'm not going to say it never can. I tested it. I got it as lightweight as I could, but it is possible to overtax that computer pretty easily. So that's why we don't do this by default. You have to record it. Okay. Any questions before I switch over and let Alan show just a little bit of the Smart Dashboard?
Go ahead and lay it over to somebody else.
Is there a problem with the little one getting full if you do too many of these recordings? I guess
Yes.
I'm not sure how big the files are.
They have had different hard drives over the years. So one year it was a solid state, pretty small hard drive, and yes, you could fill that one up pretty quickly. In fact, they could no longer give you Office. Microsoft was donating Office, and they didn't have room for it anymore because of that computer. Now, this computer, somewhere on there's an SD slot, and you can insert more storage with the SD card, and that's not very expensive. So if you have one of those, that's a cheap way to keep it alive a little bit longer. But
So you just think we should offload the log files?
you can also offload the log files periodically. The place where almost all of these things go, let me show you real quick, is in Users, Public, Documents, FRC. So we sort of claimed this directory as our own. I don't know why this is so big. So this directory is where a lot of these utilities go, it's where a lot of log files go, it's where a lot of stuff goes. So we did it for multiple users for a reason, so that's why it's a public place. But this is where your log files go. Yeah, and I've put some stuff in here, it comes from events in the past. And these are where my dashboard log files go, and these are AVIs, and so if I want to open up my video of me testing this out at home, you know, so they're not very interesting, but this is basically, you know, what you do when you don't have a robot. So, any other questions?
We're gonna get lab view and we get the smart.
You get way more tools than you need.
Okay. Just trying to figure out all these things.
You get LabVIEW, you get C++, you get Java. There's community stuff for Python. There's CAD tools.
Okay.
There's going to be schematic layout tools.
There's
building circuit boards.
Different math stuff. There's the new whatever.
You have at least 2 CAD languages.
Yeah. Yeah. And
It's very rich.
yeah.
Okay.
So
You
can
and a lot of
really
that is figuring out what your team wants to use and using it if somebody has experience in it, or just learning and training and then making that your standard.
Yeah. So the like the test mode and autonomous or auto stuff. Is there something on like the WPI with spring steps or whatever? Kind of talking more about that. Because you were talking about how a lot of teams use it wrong, and I definitely am interested in researching that more.
well, it's not so much that teams use it wrong. It's just they don't even realize it exists.
Yeah, yeah.
Or they don't take advantage of it.
That's right.
And so, just to explain, I mean, we put that in after a lot of the Einstein stuff happened in 2012, and all the time was spent, analyzing what happened and writing reports and doing kind of crazy things. And so the tools got improved, but the documentation was what suffered.
Yeah.
Right. So basically, there's features in there from that year, especially, that just don't have good documentation, and there's things added almost every year. We've been better about doing the documentation than that year, but that year there were a lot of changes made and the documentation wasn't updated.
Okay.
So
So
in
it's
hindsight,
mostly
that's
just
just
kind
a
of
mistake.
messing around with test mode and seeing what
Yeah,
happens.
but I think there's documentation up there now. It's just a lot of people assume that they know what it does. They don't need to read it.
Yeah.
I just wanted, I was just thinking about the RoboRio. It's Linux, so kids can put stuff on there of their own devising. You need to watch out for what they put on there, because it could slow your whole program down. Like one kid came up with the little netbook thing that just barely works anyway, and he had put some kind of network operating system on there, and all of a sudden that wouldn't work there at the driver's station, and he couldn't figure out why. It worked great when he had a network set up at the school. Well, it worked. I don't know about great. So be careful what kids put on there. Watch what they put on there, because it can mess you up too.
Yeah. We have an easy way of re-imaging it, but you're right. You have a command line. It's yours. You can do it with a hammer, or you can install bad software on it.
Kids may think this is the coolest thing ever. Yeah.
So there's an imaging tool there for a reason, to put it back in factory mode.
And it's hard to brick it. Very hard to brick it.
Very hard to brick it. I mean, it's the same as we do for our industrial products. Yeah.
That means that it won't screw it up for the moment.
Right. So then you image it, download the code again.
I just get paranoid about stuff like that now.
And most kids won't know how to get to the command line unless somebody shows them to. So
But the best programmers are the hacker kids.
They're looking at that.
Right, but I mean that's the matter of you have to trust your kid to do it right and perform well in the field. So.
Yep. And make sure they understand that a lot of the kids are relying on it working. So I mean, if they want to have fun, that's one thing. But there's 10 other kids on the team, or however many that.
There's 8 other months to have fun.
Have fun in the office.
Anything else? Or do you want to show a little bit of?
Let me see if I can get it to project, because we can get because people were asking about this Java one.
Yeah. And like I said, this is something, I was just talking to Brad on the way down here in the car yesterday about how we can make these more compatible.
So besides for it not liking a projector and being really small, so this is the entire year's worth of stuff that we throw to Smart Dashboard at various times. We get rid of some of it. It hasn't been cleared since we were debugging, probably at like champs in both of our off seasons.
Cheesy inverts.
So depending, we have both cheesy vision and we have cheesy drive, so depending on what we're referring to. So a lot of this is gibberish unless you're one of the 6 to 7 people on the team who knows what half of it is. because you either have to program or know what we call things in programming. So random stuff like single ball low goal drive speed is how fast we drive into low goal when we're doing a low goal icon. So we can, if we want to really break low goals, we can set that to 1 and we'll just gun it. We try not to do that. Yeah, really. Collector outspeed, that's how fast we spit a ball out. We can change that. We can make it positive, and then we would never spit the ball out. We'd always just collect it. That'd be bad. Whether red or blue, we can set all sorts of things. This turns on and off the compressor, even though it's not labeled. That checkbox is very simple. We could make a label, they just never did. You just know that the one checkbox is the compressor stuff. But you can do all sorts of things. This is pressure. You can make all these values different. You can make them graphs, so you can see when we do pid tuning, we're graphing all the outputs, so we can see error, we can see set point, we can do all sorts of things that change. You can play with it a lot.
And like I said, the real point to this is so that when you go start talking to the kids about what the robot's doing, know what's it really doing. You know, what's the speed, what's the number. Both of these, like you said, they're customizable, and you want them to think about this as a part of the robot. That's why it's there.
You know, before you said all this were like binary code, so I just assume you cannot change anything. So where are you supposed to?
Oh no, the dashboard, I didn't show much about the dashboard, but the dashboard is completely open.
Okay.
There's a binary one that's shipped, but you have a template to these things. You go in and put, they don't have their camera up here. A lot of teams have the camera up.
We don't run a camera back for network issues, but or that we don't. The driver needs to be looking at the robot and not the laptop. So it's kind of like having a camera in your car. Don't look at your rear camera when you're driving.
So the upper part is your dashboard, and the lower part is still the.
This is the part that is closed for security reasons.
Yeah.
Yeah, and this is how you turn on and off your robot, do things like that. This is your dashboard. You get to put tachometers on your dashboard and other things you want to do.
You can do whatever you want.
Two applications, you have to open.
Correct. There's 2 applications. That the driver station auto opens the dashboard. Yeah.
So yeah, I was going through this very briefly before, but this is actually where you set the kind of dashboard you're going to use. And you're even able to put this out on another computer if you want. If you want, you can bring a second computer and put them side by side, and all of this will go on a second computer.
And you can do, with that you can do it even without local or remote because it's all network tables and it'll just communicate. So actually, we use network tables even when we had a coprocessor, and all it was doing was feeding one of those values on the smart dashboard. So it's a network protocol that's just over TCP, and you can change values, you can read write whatever you want. So at the beginning when we initialize, some of those values are put up there for humans to enter. Some of those values are auto updated on the robot every time. So all the auton config stuff is updated once at the beginning, then we can edit the field and the robot's reading it in. A lot of them are things that the robot is outputting every single cycle it outputs every time we run through the code. We don't have too much of that, but like pressure is that way, some of the other diagnostic stuff is that way.
So between this local
right line
dashboard
sensor
and the
voltage is
remote
that way.
dashboard, you cannot choose both. You can only choose one of them.
This is a little bit of an old switch. The local one gets started automatically, so you just, in fact, the way we recommend you set up your computer is you log in as the driver, and all of this stuff just opens. Yeah. And it doesn't run anything else.
The only reason we don't do that is network stuff. It's really annoying to make network config when you're in driver mode.
Yeah. I mean, it was made for a lot of the teams that needed help, just making it very simple. The remote dashboard just talks to a remote IP address. As you said, I mean, the dashboard, you can have as many dashboards as you want. You can run them other places. This was just kind of a suggestion built in for us to help you do some stuff. That's all. And this is really just launching a different thing by default. That's all you do. Yeah, so you can launch it yourself.
You could write your own whatever dashboard. There's teams who write their own dashboard things and APIs and custom stuff.
Yeah. There's an executable called dashboard, and this will launch it. But this one is not an executable. This is where it usually puts the normal project. And this is where Java puts its project. So while you're developing, this is more helpful than afterwards. That's all.
Questions?
How long does this take?
What?
I mean, realistically, we're not even a team yet. And I can just envision if my students don't look at this until January,
That's not a good idea.
That's not a good idea. Okay.
That's a bad idea.
How do we get training to the students so that they have an inkling of what to do come January?
The screen steps training stuff is up there now, and you can have people look through and again find out who you think are going to be your programmers. There's a lot of resources up there.
Okay.
Other teams have put up little
There's
20 slide decks of how to do X or Y or Z. You can find other teams that will come over and answer
And if
questions.
you're willing to leave, you can go to people's shops all the time. I mean, our shop is basically always open. Like, we meet even during the fall. We meet basically 5 days a week. We're almost never here on Saturdays. We're out doing something. But
So-
you can come by, whatever.
So you have a programmer who knows what they're doing. How long will it take them to program the game? Is that?
It's a whole season of iteration and development.
Okay.
I mean, look, but how long? I mean, that robot's not finished though either. I mean, we're constantly iterating everything. So getting it to drive and shoot and stuff. I mean, I can sit down and do it in half an hour because it's not that hard to send outputs where you want to go once you know how to do it. But getting it to where it reliably plays the game and supports all the functions and the human interface makes sense takes time.
Okay, I have a student asking how long is this going to take. I'm in 5 AP classes. Yeah.
It depends a lot on their ambition level. So, yeah, I went to DC. I was CSA at DC, and they lost their robot. They didn't make it to the event. They also didn't have their programmer. So there's a kid who speaks Spanish, and they're building a new robot, and he and I wrote the code for their robot in under 20 minutes.
Okay.
Right? So it doesn't have to take long. If it's a complex robot, it will take a long time.
Okay.
Kids can make it take a long time, even if it's not complex.
Okay.
And when you're doing, and a lot of it comes into, the code can be written, but it's debug and tune to make it work well that's hard.
Okay.
And actually, the robot that comes out of the kit, once you image your RoboRio next year and your netbook and everything, the LabVIEW code, it'll drive. I mean, you can drive it straight out of the box.
The template code for all of these is a very good starting point. The kids can choose to ignore it later. Don't let them do that too soon.
Yeah.
Okay.
That's true for the examples. That's true for a lot of the documentation. Some of the kids, it's personality. Some of the kids refuse to read it. I'm going to just explore on my own, and that's how they'll make it take longer. If they want help and they want examples and tutorials, they're there.
But keep in mind, for a rookie team, it's a good idea to just get a basic, what I call a boring robot that drives from A to B, right? And so for a rookie team doing all the dashboard stuff might be a bit of a stress for the first year, or at least the first part of the first year.
Okay.
So you could ignore all of the dashboard stuff as a young rookie team, and just get a robot that drives from A to B. That's what I call a boring robot, but boring is good in this case because it works.
Yeah,
does
get
the
it
job.
to do something little, and then when your programmer is bored, say, go figure out how to output that value to the dashboard, and then they'll spend a couple hours doing it once, and then they can do it again when you actually need it to debug something.
But don't get intimidated by the big complex robots of the team. There's teams around here that are just outstandingly good, right? So don't get intimidated by the complexity of their bots. Basic boring robot.
Right, we have lots of years of experience, and also feel free to use that resource. Like Houston and all of Texas has very good teams and pretty decent density if you're this side of I-35. So go ask them for help. Say, hey, when are you meeting? Can we come down? And almost every single one will say yes. I've got very few no's. Even people go through government restrictions to let you come play with them. So like.
One thing we've done in the past is we build a test board, just get a piece of plywood, and screw down things just like this, and put on for us with the C-Reel, put on the RoboRio, put on a motor controller and a motor. And there's another programmer, make it turn. I don't care what direction, just make it turn.
Correct.
Plug in a joystick and have it so when you go forward, it turns, it goes backwards, it turns in the direction. Simple things. Okay, great. Now put on a relay, make it do something. Now put on pneumatics, extend the cylinder. Just do one of each, because if you can make them operate one cylinder, they can operate 10,000 of them. If they can't operate one, it doesn't matter how complex you want it to be. But to have them do give them a chance to succeed, little steps at a time. And before you know it, they're writing code for everything.
So similarly, I mentioned simulator a couple of times. This is for the kids who are just programmers, and maybe if you don't have access to all of that, the simulators are another way for them to practice writing the code and add things and change things and mess with the joysticks. And basically they're controlling a robot in a video game. It looks like the field. They can go push a ball and it bounces around and things like that. So some kids find that really cool. So that's another thing that they may use. They may not like it.
And those were at step line as well? The simulators were at step line as well?
The screen steps, yes.
Screen steps. I can't read my writing.
Don't worry about that.
Are they working? Are they working?
The LiveView simulator's been there for several years, and it works.
Oh, for C++.
Yep. They chose not to connect to our simulator. They chose to go off and do this other one, and it's taking longer. So, but yeah. I guess the only other thing I'll say about the programming is that I keep harping on the know what's going on the robot, because a lot of people, when they start programming, they know what they meant for it to do. Writing the code's not hard. Making it work is, right? And so really, it's what's the right size to increment on in your job. It's easy to put a gyro on the robot. It's easy to get the gyro to sort of give you some number. It's harder to get the gyro to initialize correctly. It's even harder to have the robot point in the direction that you want it to using the gyro. So trying to do all that at once is a bad idea. And you increment your way through it and you debug it well. I have a whole other presentations. There's plenty of stuff up there about how to use debugging tools. Far too many teams don't. The only thing they do is a text editor and run, and that takes forever. And then the first thing you do is teach them how to do print statements, teach them how to set breakpoints, and teach them how to debug. And those are really good for if they're going to do programming of any sort in the future. They need to learn how to break things down and how to debug. LiveView has a ton of debugging features. Smart Dashboard called it up about debugging. And part of this is not even just your code; it's debugging the robot. It may not be a code issue, but they're still looking at you to fix it and figure out why it's broken. So, that's really the hard part. It's not writing the code; it's getting the code to work and understand when it doesn't and when it does and all that kind of stuff.
Getting the code to work, the whole tuning process, and just getting everything set up and working well. So yeah, give your programmers time. If it's a proto board, if it's an actual robot, if you can have one or an old robot or something along those lines, getting something where they have time with it and no one else is bugging them to try to fix a mechanical feature. Because yeah, it takes a lot of time. If they can do it on the simulator, if they can do some way to put code on it a bunch of times, it helps a lot, especially when they're just starting out.
One problem I've seen. Go ahead.
Is it Greg? You said two things right there, I think, that I was going to try to say. I still want to piggyback on. One is you mentioned the word increment, and the kids want to do big increments, and it's about getting the smaller increments so that you know this is working before you go to the next step. Because if they do like all 5 of those pieces with the gyro, you don't know where the failure point is if it's not working. And the first thing I'll ask them is, what's the gyro doing? What is it actually doing? So that we can see if the gyro is outputting the signal that they think it should be. Because it may be hooked up wrong and it's not even a code issue.
Right, and that's one of the things that Smart Dashboard allows you to do. So if we're like installing a new sensor, we'll output the raw value, so like the straight, we'll talk about sensors in a bit, but basically sensors give you back, a lot of times they give you back a voltage, so we'll get like direct voltage, whatever the rawest thing that the CRO is giving us, or the CRO RoboRio is giving us. Then we'll give whatever we're calculated, we'll graph both of them, we'll graph what we're expecting, error, all sorts of different things that we can see and kind of find out where it's breaking, what's not working as well, that kind of stuff.
One of our lecturers this year was a project manager of the Connect system. And when he describes all the ordinances trying to map out the animation, it's an impossible puzzle to believe. And he brought up the fact that when you take a large project and you break it up, an impossible project, and you break it up into hundreds or thousands or tens of thousands of little projects, each little project is solvable. And so our students are starting to learn, finally realize, break it from big to small. You can do a lot of small steps easy and come up with your final solution by breaking it down and doing one small thing at a time, where we tried to do the Connect system. So there's no way we could do it if we hadn't broken it up that small.
But we know that because we've had the business experience doing it.
We bring the lecturer from the Connect in, since he built the Connect, they want to listen to him, not us. And they have started to break up their software and a lot of things, a lot smaller projects, and it makes it go much better.
The other thing is, keep in mind, simple is not bad.
That's wonderful.
One of the best things you can encourage the kids to do is keep it as simple as possible.
Yes,
The tendency initially is to make things a little bit more complicated.
the goal is to have just what is necessary to be there, and there's a lot of that. Okay.
You guys talk a little bit about simulating your software. What do you guys use to really do that? Like you were talking about your switch with the
LabVIEW has a full simulator.
Yeah, the word simulate can mean a lot of different things. Right. The other thing you'll see is that there are simulators that pop up and disappear every couple of years within FRC. sometimes they mean simulate the game, but nobody gets to program. It's just a drive simulator, video game kind of thing. That really doesn't help the teams much, I don't think, except for strategy
as far as I know.
and for recruiting.
Yeah, the big company that was doing that, it folded as far as I know.
Yeah, but another one will come in.
Probably.
You know. So the other thing is just running the libraries and getting results back, right? So I need to run my code. I'm going to return random numbers or whatever, but you can run a lot of this stuff. You can run it. It's just Java code. It's just C++ code. The WPI line stuff may return errors or things like that, but if you can get into it, you can just run your code and make sure it's not going to crash or hang. That's useful. That's not a full simulator, but it's a useful environment thing. The LabVIEW one and the Gazebo thing that WPI was working on is a full physics engine, like you would see in a game, but you can actually bring in a different robot. You bring in a holonomic robot, bring in a two-wheel drive robot, a four-wheel drive robot, things like that. Hook up different joysticks and run your code and debug your code as it talks to this physics simulated robot, right? That actually has game elements in it, and you can pause time and slow down time and do crazy things like that.
And where were you opening that up from? Is that like in the utilities app or something?
So there's a tutorial telling you how to do it.
Okay.
But what you do is you take your robot code, you move it to a simulated target. LabVIEW targets all kinds of different hardware, FPGAs and all kinds of things, including simulated hardware. So you move it to a simulated hardware that knows about the physics engine, and you run it there, and the simulator just opens up and shows you the world within your simulator.
Okay.
So it's actually very easy to use. I can show you on my laptop later if you want to see it.
I might.
But projecting it and doing all this other kind of stuff is not worth the headache on Parallels machine and virtual machine.
No problem.
One thing with the new Rio, when we transitioned from the previous brain to the Rio in 2009, there was, I think a few teams used the old brains as for their backup bots in their shop in the next few years. But it was not an easy plug and play. You know, your old robot's not easily compatible with the Rio. Is that going to be much smoother this time since it's still NI and still pseudo Rio-ish?
I think so. I mean, that's what's happened during Alpha. So the Alpha teams, took out a C Rio and put in a RoboRio.
Just on plug and play.
They're not going back at this point, but they could. And there's not many code changes either. As they make code changes, they may make it less compatible, or they may take advantage of new features. But there's a huge amount of stuff that is the same.
Okay. So if you were crazy enough to load last year's code on the new Rio, that would likely not work very well.
That's the first thing we ask the Alpha teams to do. Yeah, and it largely works.
Yeah, and to go back,
It's
you would just have
different
to
across the three
remove
languages,
stuff.
but it largely works. I mean,
So-
we'll be going through it soon.
So like my plan, not even seeing the code for the Java stuff, is to have some sort of flag that basically says this is new stuff, and when I change something, it no longer will change some variable, and we'll be able to load on a C-Rio. It won't run the new stuff, like the CAN stuff that'll be on the RoboRio specifically, but it'll run everything else. And there should be a way to be able to make a very, very similar file without changing a bunch of stuff that loads on both robots. Any other questions? I think we're done. All right, enough control system-y stuff for a bit.
Oh, Greg.
Yes.
When is the beta testing finished? Do you guys have a timeline for that?
Finished.
It
Kickoff.
just started.
Do you know the details?
It ends at kickoff, I'm pretty sure.
But it ends before.
It ends before kickoff.
Generally, the goal. So this is a transition year. So you don't really know until you start how many things you're going to find and how valuable it is. Generally, they try to stop though early December. They don't really want kids to be doing this all the time, right? It can become too much of a drain. I think officially it tries to stop even earlier, but usually it stops around early December. It starts around August. This year, it's beginning of August.
It was scheduled to be
late July or August.
Yeah.
So I suspect that's kind of what will happen. Some teams will do it very. They're very good testers. Some teams will do the bare minimum and will stop as long before you ask them to stop. Some won't stop. They won't return the hardware. They'll keep going.
Okay. What do we want to do next? So we probably need to do financy stuff.
What?
Money stuff.
Yeah, that's what I was saying.
Yeah, that was my plan.
But I have a
Whoa! I had to go to drop our driver
Not
station.
money. Yes, I don't know, do I have a segue for money here?